All right, everyone. Welcome to my stream today. I've been last minute doing bug fixes, which is pretty par for the course here. It's one of those things. I didn't advertise a stream earlier just because I didn't have time to create a cover. And then as soon as I'm like ready to advertise it, I realized that there's actually a pretty big regression that would actually get in the way for me doing the stream. So I fixed that this morning. But I still haven't done the latest the latest stuff. So for like a new beta release. So I'm just actually in the process of pushing that out right now. Nice. Okay. So everything is perfectly clean now. So I'm just about to press go on that PNPM change set version. I know you guys can't see what I'm doing because it's on my other computer, but I'm very excited today to go a little deeper into Solid 2.0. We've talked a lot of theoretical stuff. And then the last stream, I knew that the beta was going to be pretty broken out the gate. So I just used it as a excuse to kind of test it, right? Today, I've fixed a lot of stuff in the last 2 weeks. So today, I think we can actually like showcase some mechanics a little bit better. I mean, not that last week or 2 weeks ago didn't showcase some pretty cool stuff. But yeah, anyways, yeah, everyone come say hi in the chat. The AI thumbnails are getting out of hand. I want to talk about this a bit too, because see, I have a very different perspective, and maybe it's because of my age, and I think maybe this is going to be one of those things that, like, when people call people boomers or whatever, that kind of perspective. I think my perspective on AI is kind of like they'll be probably making fun of millennials, in a few years, because I don't like a lot of people see a lot of AI stuff and they consider it cringe because I understand because of the low amount of effort it takes to generate or create stuff. But if you were going to spend a low amount of effort anyway, I think the output's better. I don't I don't like I've been getting a lot of pushback on using AI generated images, and I'm like thinking about what I would actually use instead. And I mean, we can look at this on stream, actually, give me a second here. But let's look at the YouTube covers that I create versus the YouTube covers when an artist creates them versus the YouTube covers that AI generates for me. And you tell me which ones are the best or the worst. But we can do this right now. Yeah, we're gonna talk about this article a bunch today because I realized kind of like in hindsight, like I'm very much down on a path, and the article is an introduction of some topics, but a lot of people are like, yeah, so what? What does this mean for Solid? I'm like, I thought I laid that out, but I didn't connect those dots. So yeah, I would manufacture these. Yeah, yeah. Well, I am a programmer, not a visual artist. So I'm going. This is kind of what I want to. Let's just do this right now because I honestly I keep on getting this feedback, and I'm sorry, you guys. I think it's a very. I think you kind of got to look at it for what it is. So let's look here. Let's go to my YouTube channel. And yeah, let's just call it out right here. Okay, so these are some video covers that I made myself. So these ones, actually AI generated this image inside the painting. David made this image. I did this one, and I did this one by just putting these three labels on top of a pre-made image. So I didn't really make this image. Okay, but let's look at my live streams because there's more examples there. This is a live stream cover where I took a stock image. This is an AI generated image. Actually, let's just go right off the top. Okay. AI generated, AI generated, AI generated. Actually AI generated, but then I put the labels on top. This one is someone's art, so I gave them credit for it. I found someone's art. This one is AI generated. This one I found a stock image and put the word async signals above. This one I found a stock image and put micro frontends done first. This one's a screen cap from a talk. This one, an artist actually created. They took the image and they put it together. Or no, maybe I did this one. I feel like this is better than my average. Guys from Marco made that one. This is from a slide. I took a pre-existing image and put a slide on it. This one was AI generated. This one, I took a table and put my face on it. This one, I took an image, put my face on it. This one, I took a photo that I took on a mountain and put my face on it. Image, put my face on it. This one, actually, I had to layer some fire on top and a logo on top of a sci-fi image, screenshot image. Oh, yeah, look at this one. I just took an image. I also just took an image here. This one's AI generated, kind of looks weird. I like that these old AI generated ones are a lot worse than the new ones. Like they actually garble stuff in a weird way. Took some like Iron Maiden background and put a logo on it. An artist made this one. My point is I don't. An artist made this one too. I don't know if this was AI help, but this was made by an artist. Stock image. My point is I actually think on average the AI images are better than like when I do something like this, like where I just like take some stock image and put a font on it. For articles, I love low fidelity hand-drawn sketches than AI. Yeah, I mean, I'm not going to hand draw those sketches. We can do the same exercise on DevTube. Because, I mean, I forget where I got that image from with the solid in there. Someone might have created it. But if you look, my articles are infamous for using like clips of Twitter, and which is why a lot of them are no longer around, or meme drawings, because literally I'm not creating the art, right? Like I find like stock image clips and then I find memes to support them. Like occasionally there's diagrams, but see, one of the things I learned really early on with articles is, especially dense articles with a whole freaking lot of text and a lot to get on, you have to kind of force the gaps in for your readers yourself, because otherwise if you just give them the blob, it's going to feel heavy. It is already heavy. So things you'll see that I do very often is between sections, I'll add extra like line spacing, like these kind of dividers, even though I don't really need to. I learned this earlier from editors when writing articles. Is just you're writing highly technical articles that were very dense, and people will probably reread sections multiple times and they'll try and get through it all. Breaking up the flow is incredibly important, even if it's just like for spacing things. Like these are just blank spots without any images. The images let them like temporarily relax their brain. So like there's a whole like I will fight people on this AI image thing, because to me it is 100% improvement. I don't understand how people could even argue otherwise. They look cheap, but are they worse than me literally going pixels, atomic, atoms in space? All right. Reactivity expanded, cover, chopped. Like that, this is basically what you're getting in here we go. This one looks like one I would use with a like a graphic designers can do the work, but am I going to hire graphic designers every time I want to write something? It's just completely insane to me, the pushback on the AI image generation stuff. I get like if that's not the primary goal of the thing, and the actual goal is mechanical in terms of actually spacing and writing, like as I said, the memes where they fit are a lot better, but the images are also valuable. And if you look, I've been using this pattern forever, even if it's not. I also, obviously have code examples where I can do it, but in stuff that's fairly like conclusion, like what is this? It's a spinning top. I mean, some of these make you think more, but let's compare this to like an AI generated image, right? I actually think this cover makes a lot of sense, right? You have like signals kind of like flowing through, and then you have like this rocky, hazardous place, but then where React sits, and like it actually has more contextual meaning in terms of what the actual article is about, right? Sometimes these text things are a little bit existence, but like it actually better corresponds with what is being said. And obviously if I don't like the images, like I kind of tweak or look at the like the kind of takeaway, right? Like the art of actually choosing these images is like a little bit tricky anyways. Like client-side routing without the JavaScript, does that cover make any sense to you? Like it makes sense to me. I'm playing on it. I apply the same kind of thought process into how I look at AI images when I find like an opportunity to kind of play around with the idea. Right, like to me, the process is the same, but the results are just infinitely better. I don't, I don't, and the funny thing is, I've been getting pushback on this repeatedly, but it's like, it's not like the pushback has an actual workable suggestion or solution behind it. It's just like, I don't like this. And it's like part of you got to go like, okay, well, I have to think about why they don't like this and what that actually says. But then when you like think about the actual output quality in a holistic sense being better, it's hard to like really care that much about the I don't like this. You don't see the value in creating an image yourself, then you can't pretend any image in the article adds value besides space. Yeah, that's what I'm saying. It's mostly space, and then like a little bit of like visualization of a concept or a relational thing. It's just enough to trigger the mind to be like, oh, okay, I'm getting out of the words. I'm just like, you know, I'm like, it's a distraction. Yeah, sorry. Like, I, I think when I actually like solid start. I mean, some of these like work. I mean, I don't know. As I said, this is going to be probably considered a boomer because it's or type take or millennial take or something, because what I'm doing is arguably distasteful, but it's like what it's replacing is not actually good in any like intrinsically better in any sort of way. So like the people are like, oh, well, just get rid of the images. It's not. That is not the solution. So what I've done is found a way to streamline like my process to actually make a tangible improvement. And one thing I've noticed over time is that like the AI images have gotten better, and over time, I think one of the funniest things, and we'll talk about this in a minute when we get into this article, but I, there's there's something really funny here. I have a conversation here with a response in my to my article here, where someone's like, let me see here. Where is it? I thought it was really funny. Let's see if I can find it. It was one of the very first responses to my article. Let me see. Okay, this one here. The uncomfortable truth you're naming, signals didn't fix the async problem, they just delayed it. React awkwardness wasn't a mistake, it was a shape that constraint becoming visible. The frameworks that pretend async is special case are the ones that will break first when the graph gets complex enough. Yeah, thankfully my work with two has shown that we don't need to be mutually exclusive things. We can consistently address async and keep all the advantages of signals. We just have to be open to it. Difference is you're building the constraints into a design instead of pretending it doesn't exist. That's the line between a framework that teaches you something and one that gets out of your way until it doesn't. Looking forward to seeing where Solid 2.0 lands. This was the first comment and response on my article, and I was like, wow, someone gets it. You know, like this is a really reasonable, well thought out response, and like a lot of times these are not the kind of responses I get. And then I make small clarification, and the person seems legitimately excited about it. I find out later. Are we having a discussion about AI images and stuff? Yeah, a little bit right now, yes. These stock images are charming and authentic compared to AI generated ones. I suppose they feel stolen, and they like and they kind of miss a little bit. I mean, yeah, I mean it's tricky. The stock images are great when the artists give them for free, and then I can just credit them. Obviously, paying for stock images is a whole other thing. It'd be interesting to basically guide the AI to have the aesthetic of stock images. Like, there's something about the stuff that, like, as I said, really is repulsive to some people, but doesn't bother me in even the slightest. But sorry, the reason I brought up this conversation here is apparently this isn't a real person, and I was actually talking to an AI, and I had no idea. Someone actually pointed this out to me on X. So, like, you realize this interaction was with an AI, and I was like, no, they just sounded like the most reasonable person that I ever come across, and I'm like, that should have been my clue. If someone responds reasonably, they're probably not a real person. And what I'm getting at is I'm expecting these lines to blur even more in the future, to the point that the like current distaste that we're experiencing right now is going to be basically meaningless in a short period of time. Obviously, you will be able to tell, at least for a long period of time, the craftsmanship of a true expert, like of someone who's actually really good at what they do. That's hard to replicate. But if you're not in a position to pay someone to commission your artwork, like, the funniest thing about this is, we'll talk about AI writing too, because I want to talk about this a little bit, because and we'll get into the topic today, but I want to talk about this again, because it's like, again, this is an example of where people's distaste of it. I read stuff for its value. The reason I don't like AI written stuff is because it isn't valuable usually. It usually regurgitates. It usually doesn't actually provide true insight. It usually doesn't position things in a sensible argument. It's too, like, the way it thinks what's logical, presents its argument, isn't like really all that compelling. Sometimes it feels like it's being like smacked at you with like a hammer. But if an AI generated article actually had relevant content, I wouldn't care if it was AI generated. Again, this is like such a weird constraint. The content is more important than the delivery. You know what I mean? Like there's an aesthetic artistry to certain things, but if that's not your primary outgoing goal or goal, who cares? Like the important part is to clearly communicate. It's not like, again, this is why I get the impression that my perspective is going to age very poorly or something because people might care about this stuff. But from my perspective, it's like focusing on the wrong things. People, like, I don't get, like, okay, let's flip this example around, hypothetically, right? Like, AI makes me feel undervalued, underappreciation. It's like the person didn't care enough. Flipped around, does it mean that the person found a more efficient way to get to the same means if the content is actually valuable? Like I'm just kind of throwing this out here. There is craftsmanship in the art, and if you have the time to do it, there's probably real value there. But otherwise, like, who cares? I mean, there's definitely misguided. Okay, and I want to give an example here because I agree with you. Like from the perspective of like earlier in the week, before I posted this, where I very clearly I basically asked AI to write me an article, right? Um, and sorry, let me just quickly get this release going. I just need PM change set version. I just want to see if I can just hit commit, so to speak, on this. Yeah, beta 4, beta 4, beta 4, beta 4. Okay, cool. Sorry, v2.00 beta 4. That way, like, it'll all be out there by the time we're actually doing anything important. Okay, perfect. And then commit that. Pre-commit, what the? It's fine. I'll get freaking, it's being weird right now. Some weird. Okay. But my point is, I wrote this forward here. Oh, sorry, just reading some chat here. Just draw some simple sketches that help neurodivergent people stay on a topic like Theo and Pirate software does. I will do that during my Scala draw. I have something to think, but like for articles, like you could be like, you should spend an extra 45 minutes to an hour actively working on your articles if it means the images are better. Or you, but like I have the code examples where they're relevant. Like here's an, like sometimes I will just use the code highlighting instead of using an image often in my articles. I don't have infinite time. This is my secondary thing. So I mean, I guess you can appreciate that. You can be like, look, I don't appreciate that you don't spend as much time as you should on this. And it's like I'm looking for ways to spend less time on it. So, you know, the values in the content. We're gonna do some Excalibur today. If AI images are not for the kind of thing, what are they for? I mean, that's an interesting question. I mean, this is pretty much I think the use of AI images is for like presentations or like little like, yeah. Okay. Okay, now let's do this pm build, pm test, and if this all goes well, I will be releasing beta. In this case, imagery are side dash to the point, not the art, and it's not there as the only main consuming the content. It's more to help pacing the reading. Yes, exactly. Okay, so I got AI to write something for me, and this is going to be relevant more to the content of the stream because I was like, I've been talking with Copilot a ton and like going over stuff, and I was like, which is more just like my think out loud thing. And I was like, I feel like all of these aspects kind of are pointing at a bigger truth. Can you help me like put that like get more tighter on what that truth is? And so I wrote this forward, and then AI wrote the article. And I've written, if you've seen on the stream, I've used HackMD to generate article type stuff in AI lots of times as like concept stuff, just like kind of like, oh, give me a sales pitch or a message to contributors or like some kind of like different types of writing. But you're right, they all kind of, it's not, for me with AI, it's not the phrasing or the pacing as much as like the line of argument they take is very indicative of like their personality, right? So like for me, when I look at this, obviously there's a lot of AI like things here, like the limiting factor is no machines. I'm looking for like the really there's always those real like I'm just gonna drop this in chat. You guys can probably pick out the AI isms like hugely. Yes, Unsplash they didn't add much value anyways. Yeah, pretty much as far as I'm. So for me, this is that it's just an upgrade. Okay, so I'm gonna drop this article in here, um, the one about determinism, and you could probably see some of the telltale signs of AI here. But on the other hand, as I said, like I've done enough of this that it's very obvious, at least for me, when I'm like writing something, like I can't get AI to write the article I want to write. This one is basically a point form list, so it kind of works. But you can never get it to write a real human feeling narrative, I find. Async is no longer a side effect. It's part of where the value is identity, limits needs ad hoc. I do think we should this whole thing is probably worth talking about. March 9th, did I cover that on my last stream 14 days ago? Would have been the 4th. So yeah, we should talk about this content on thing. But my point is like, I do find myself using AI in new and interesting ways while I'm working on stuff. Like for my article that I did post, the one that we're going to go into today about React and variance thing, I basically asked Copilot, and I extracted this out at the time because I didn't want to like lose it in the conversation. I said, let's say the outline below is an optimized for that title, sharp, confident structure to both values. Where is it? Depending, the article now reframes in as two Iterators streams, still find the link correct. Basically, I asked AI at the very beginning. I was like, I want to do an article about this, but I want to make sure that I don't miss any of the key points. Can you like give me like a rough outline of like all the points I should touch? And it did. And kind of like gave it like sections. The funniest thing is if you actually followed this for writing your article, you wouldn't end up with a very good article, in my opinion. And in fact, this is kind of what AI would have generated if AI had written the last article I wrote, because it would have been like, async rejected because to write the sync constraints principles. Color sync track these reactive and the right variants, but the wrong model around them. Shared constraints, both variants ran into modern UI's default stream transitions. Cannot have optional color nullable, why nominal for suspense, blah 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 blah. Design decisions got right, must be exit from commits, blah blah blah. React got wrong. We're predictable double renders, effect choosing rule to hook. What's all to like you could already see that it's trying to build a narrative where it's like us versus them. Because it's very to the point. That's the way AI doesn't like leaving things open-ended. It doesn't like talking about general truths. It's like it wants something actionable out of it. So it's like every single section in here is like structured in this kind of like, and this is why you should do solid, blah 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 blah. And it's just like it's a bit much. And this is kind of like you could almost never trust, like I can already see the narrative gap that you find in these kind of articles. AI is biased towards sounding smart. Yeah, everything is bullet points. Yeah, I mean, I asked for it. If you actually want to see, I could probably pull back the original prompt on this. But I was like, give me an outline. Do not write me an article. Just give me an outline of what you think the key talking points would be around blank, right? And then I took this and I just started writing, and then I was like, and I kind of just like I was like, okay, this is not the narrative. But what this is useful for me was it was very helpful for me to be able to identify like I mean, I already knew this stuff, but it kind of laid it out. So I was like, because the hardest part about when I write articles is, and my normal process is that I end up just like writing huge blobs per sections and then deleting like half the paragraphs because I write too much. And then I go back and I'm like, okay, I realized something in this part, but I need to get it back into the original message. So I end up rewriting it again, and then I rewrite it again, and then I rewrite it again. Obviously, if you learn this in grade school, if you start your article with an outline, you can at least know that you don't forget anything, so you can actually write it into the initial narrative. Right? To be fair, it got all this information because Copilot might have a short context window that it keeps on sliding stuff out, but because I mean, I can probably show you here because of like all these conversations I've had over time and like things that it's kind of frozen into memory currently. If I just jump in on a new topic today and ask it about some aspect of Solid 2.0 or something, it doesn't like remember the specifics, but it remembers the general thing. So like it's very much, it knows in principle what I'm trying to do. So, when I give it I was trying to, this is how I got the idea for the stream title today. Because I was like, I've been doing a ton of Solid 2 beta fixes. It's been 2 weeks since the last stream. I also published this article. It sounds like one of those deep work sprints where you disappear, but dropped a big piece of thought leadership, blah, 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 blah. I need to think of tomorrow's stream and I need a title, concept. Hidden physics of React and how Solid 2 solves them differently. Blah, blah, blah. That's ultimately what led me to where I am today. But it was it doesn't take very much context because of like the baseline that I've set for it to be able to jump directly into like what I need out of it. Um Section R1 Solid 2.0. Let me see if I can. But I know people were really interested in this, so I'm going to show you this because this is actually a multi-day process that was going through while I was writing that last article. I need to write an article around the two controversial changes Solid 2.0 deferred commits and split effects. I don't want to write the article. I don't want you to write the article. They clearly have an AI voice, but I'd like you help laying out the structure and the points. That's how the conversation started, right? And then the thing that I copied was I gave it some clarity, blah, blah, blah. And the thing that I ended up copying was right after I was like, so still giving it clarity. I'd rather lay out the article by headers and bullet points. And then like, how would you change this on where how would you change this on by changing the title? And then this was the thing that we just looked at. And then I just started dumping my literal intro and I ended up rewriting the first thing because it didn't tie together. But if you look at this is like basically verbatim of like what actually ended up in the article, and except it basically was like it was it it added like As when you know, so yeah, I got rid of this part. It's all too left to. It's been a journey. Like it basically added the right periods and commas and kind of like semicolon type stuff. Uh, so then strong section, media pivots, this, then it's like, okay. And if you look, what I end up doing is basically taking, what do you think about framing for introducing async characters? I basically just dumped, because I use Grammarly, right? But Grammarly costs money for grammatical fixes. It just does like spelling, but for complex structure sentence fixes, um, it actually costs money. So basically what I would do is write like 3 or 4 paragraphs at a time and go, can you correct the structure of this? Everything involved with foundational language response, you never did option. The async moves us out of the impaired comfort zone. Async is about redefining. That's a question what's available to scale up and coherent something consistent. Interesting flitters in and out of synchronous declarative systems. At least that way it looks in most frameworks. By the time it's a different axis, we're on the same parts that intersect. It appears unpredictable as impact the whole system. With a bit of work, you can model in a consistent way. Essentially, this process can take is essentially how I ended up with the article, right? So people noticing AI-isms weren't completely off, but I also wrote every single paragraph in here. As you know, I've been working with lots of it's been during a single threaded vote just so they do some in the more found this sort of territory. You know, where was the other one we just saying? Everything in the web building is the entire platform is built separate the network around those. You know, like I didn't add this dash, but it fits better with the flow, right? The comfort zone, right things. That's the same thing. Blah blah blah. Too much for async. Looks at ephemeral state flitting in and out. Like this is my exact wording. Like it's basically a grammar corrector. But it's enough to give us a slight voice on this that I get rubbed people the wrong way. But AI could have never written this article. Do you know what I mean? Like when you go and be like, hey, with these points, write the article. It doesn't write this kind of narrative structure. It doesn't construct this sort of. I have not had any, and this shouldn't be surprising to you because it's not like it's a bit like trying to execute a plan without plan mode. The problem is with writing, plan mode would basically essentially force you to get the right tone, narrative structure, all that. You'd basically have to write the article, like you'd have to write the whole article first to actually sufficiently do what plan mode would do for code by comparison. And this is another example, and I'm bringing this up right now before we get into the more solid 2.0 stuff, just because this has been controversial. Because there, as I said, a lot of people talked about the AI-ness of this article, and they were upset about it. And I'm thinking about like, I know what if I'd set AI to write this article, it would be nothing like this. Like I actually have the artifacts as I was showing to prove that. But when I look at this, the way it reads compared to my Yoda speak, you know, this feels much nicer, much more professional, much more hopefully understandable than, you know, my writing typically is. It actually tightens up little bits of phrasing things where I miss words. Anyone who's ever edited my articles before they get published knows exactly what I'm talking about. I used to, for years, I've used like 4 or 5 people, like different people, different articles, but I always run my articles through a bunch of human review because they tend to not be understandable otherwise. If you look at my HackMDs versus my Dev2 articles, like the ones that I write, you can tell a world's of difference. Part of it is because of the amount of time I spend editing, but the other part is because other people actually read it and edit it because what I write tends to not make sense. Copilot's like on something old, like GPT 5.1 or something. Bro, right, which is what I was doing. I was posting whole sections and being like, "What do you think about this?" That's what I'm saying. Like AI would not generate it. But when I see this come back, which is basically identical to what I wrote, but like added the spacing, timing, pausing, slightly rewords like a thing here or there, I'm just like, this is, yeah, honestly, this is much better. You know, add some quotations around my, like, is it my questioning? Like, you're just like, okay, this actually reads better. It's a question of every UI understands for anything. Can I show this or expose something? Is this like, this reads a billion times better. I mean, I've streamed for 6 hours, so, I'm sure we'll get to whatever you want to talk about. This is important though. I needed to get this out of the way, mostly because this is, yeah. Again, what is my goal? My goal is to clearly communicate with people. Yeah, this is the gist of it. The challenge is, let's say that this experiment was a little bit heavier handed than I usually go. Was it worth it? If it's less than 6 hours, it's AI. um, yeah, just replace me with the AI. Did it work? And the answer is, depending on who you talk to. I got that first comment in the comments, and I was like, yes, it worked. And then I find out that AI wrote it, and I was like, okay, well, maybe it didn't work. Which is a little bit harsh. Sorry, I should actually do the publish command now. Sorry, I just need to quickly get my authenticator app going here so that I can actually publish. Do not challenge for the next 5 minutes. Okay. All right, thank God. Okay, beta out. Okay. Yeah. The funny thing is this. I'm going to talk about the contents of these articles in 2 seconds. The last bit of this conversation is, I want to go to Reddit, and let's see if I can find what I'm looking for. All right, here we go. Great article. The TLDRs I illustrated, you basically have the deep. Oh, so the person. Oh, well, they deleted it. Okay, well, good to know. So is it only good comments now? Oh yeah, here it is. I think it would be helpful if you adjust your title and note in your post that this article is basically a subtle plug for Solid. You posted in the React sub. This isn't really advice for React dev. It frankly reads more as, haha, you React peons are stuck with this stuff and you don't have to deal with it in Svelte or Solid. Thank God Rick Hanlon, remember him? React core team had him on the stream. You're wrong. This is absolutely great content for React devs. It explains the exact reason for choices we made that I've struggled to explain to React devs myself, and several times even says it's not about the framework being better than the others. Thank you, Ricky. Thank you. Honestly, I think the takeaway is, even with AI, people still don't really understand anything. If they don't put the time in too. So yeah, I was really happy reading the article and seeing how much clearer the points were, and I'm like, oh, I wish I thought of doing it that way. Oh no, this is much nicer. Like, just little, it's the structure, this paragraph per paragraph were the same, but it was just like, oh, added this word here, paused here, and you're like, oh, okay, yes, exactly, right? So like, more people came to defense, so whatever. But yeah, this is, if you look at this article, it got downvoted on Reddit React forum, like past 0. Like basically everyone downvoted this article. No one upvoted it, which is insane. But it's also par for the course for Reddit. You know, we've often said that, like on average, the developers on Reddit are like YouTube comments sometimes are pretty low bar. Reddit is like the bottom. You know, you can like go on there, say something reasonable, and then I mean, it's almost like I think my response where I was like, it seems reasonable to me, got downvoted a bunch. Okay, that's not the message. It's 4. Okay, this was like -6 at one point. um, when I'm like literally saying like, no, that's not what the article says. Like, I'm not sure people on Reddit, like, I guess they would need to know how to read if they were gonna like write this stuff. But I'm sometimes not sure if they know how to read. Anyway. So yeah, my takeaway on this is that maybe the thing that I thought I was attributing to the clarity of my writing is actually not my writing's fault completely. I thought that if I could like clean things up in a meaningful way, people would get what I'm talking about better. It could be still a problem with my narrative structure. It could still be other stuff, you know, because that's AI obviously didn't write that article. But I like my narrative structure. I like the arguments I make, so I would never change that. But it's definitely frustrating when you write an article that's literally like, look, React fans, here's some ammo. You guys were right. And the person's like, you're just trying to rub salt in people's faces. You're just like, and it wasn't just them. Like there's multiple comments to this degree and like in this kind of thing. And I was just like, how do you get there? How like, do I just give up? Anyway, enough on the AI topic. Let's get to the topic at hand. I think I've probably talked your guys' ear off about this. I don't generally like talking too much, but I had to address this because there's a bit of an elephant in the room. Yeah. Well, we'll see if we can get Delaney on. I think Datastar is interesting because it tries to sidestep a certain category of problems, which I think in a sense the way I would look at Datastar just holistically before like going deep into it is it's really taking that HTMX perspective that you like Yagni, you're not going to need it, and just like, look, HTMX is just missing this last little bit. This is how you just stretch into that next zone a little bit farther. My challenge with this is once you introduce that zone, you have a new set of problems you should be solving, and you can pretend those problems don't exist, and you can basically be like, okay, I'm okay with it. My scope is right here, and you'll be fine. It's kind of like a bit like some of the issues I have with Astro Islands. But then it's like once you cross that threshold, it's insufficient, and then at that point, you have to rethink everything, and you can end up where I'm sitting. So it's like there's this interesting tension between solutions that you can clearly go, they belong over here, and one's trying to expand over more of the range. And the thing is, if you take those I just belong over here solutions and try and expand them beyond their range, sometimes you can hit a really sweet spot, but you can also hit a zone where you're butting right up against like models that would be more suitable for, you know, like you're just hitting that piece. So it'll be interesting talking to Delaney and figuring out exactly where that line falls. React, and especially React developers in a serious community, it seems. It is a big mind shift, but the thing is, and I think this is still true, Delaney still doesn't believe in shared client state. He believes that not everything has to go back to the server, which is key. Like that you can keep interaction while keeping that kind of like partial subview. The challenge is when you have partials that share state, like islands, same kind of concept. There's a fundamental mismatch here on shared state works with server-side rendering, right? Like how do you get the old update panel thing? We're going to talk about it, I'm sure, when I get Delaney on. It's just it's kind of fundamental. It's not like it's a physics thing, and I like talking about these things in terms of physics, which is the whole reason that I wanted to do the stream today, because these things feel like rules that are discovered rather than inventions, things created by people. And I think that's really important. Speaking of caching, the caching military is really interesting. It's like content program. I mean, it makes sense to me, especially if they're using that with something like server islands. Like, I think we just need to. I mean, there's only a few core mechanisms behind all these things. And even if we figure out how to model the data or the transport layer like slightly different, you're still dealing with the same types of problems. You can like kind of shift it around. So I haven't actually looked at this specifically, but I'm guessing I'm guessing that's the realm in which it's operating in. I could be completely wrong though. Okay. So let's talk about physics here. I'm going to change my view slightly so we can get into the topic of today. Because I want to start with this article mostly. I think my HackMD about why Solid 2.0 is interesting, about temporal determinism and all that. It is interesting, but it's kind of like a AI point, and I don't know if we want to talk any more AI right now. I think I've made this point on stream over and over and over again, essentially that the shape of our solution is important, but there's no point talking about the shape of our solution until we actually look at the shape of our solution. So let's instead start from here, right? Let's start by talking about why React was right and why this is actually physics, not DX consideration, right? And then we'll talk about how Solid 2.0 solves that. So if you haven't read the article, it's worth a read. React was wrong. React was right because Angular was oh so wrong. Or AngularJS original. Yeah, I mean, AngularJS had its challenges. I think conceptually, AngularJS came from a really reasonable place. It was like, look, we have data, we bind it, we update what changes. Honestly, anyone engineering a solution for front end at the time, that seems like what the problem was. You have a bunch of imperative writings all over the thing. Let's make it declarative. Let's just go this change to this change. Like it had the shape of the solution it knew it wanted to solve. It didn't have any of the guarantees on propagation. This is the whole problem with the early systems. They basically were just like a wrapper over jQuery, right? They're just like, okay, well, that's imperative spaghetti code. Let's make it declarative spaghetti code. Like the process in which we could like do these updates wasn't as refined, right? Back then it was just like about the abstraction. It was like, how do we get the DX? It's like, okay, we'll dirty check everything. We don't care. Just make sure that when I say that this state is tied to this thing, that it will update. That was our primary concern. React was kind of more like, no, we need guarantees here. Otherwise, it's Zalgo. Like literally anything could go wrong. Right? The problem with the React approach was it was too simple, right? It's both the benefit and the like. It's both. React was just like, who cares? Just re-render everything, and you're like, how can that be good enough? And they're like, you know what? We figured out a way to make it good enough. That's the whole premise. But it was never like arguably the best solution to the problem. but they didn't approach it like engineers solving a specific, like mechanical problem. They kind of were like, holistically, this truth needs to emerge from our system, right? And almost everything from there flows out from React. Does solid get compiled into web components? No, I don't know why anyone would want to do that. I mean, we can support web components and people can put solid code in web components, but it's kind of like web components are kind of a waste of like, I mean, they're just a thing. It's like I can have a component and then I can also make it a DOM element for some reason. AngularJS had its good sides. To this day, no modern framework has better modal dialog DX than Angular. Spent months trying to recreate meager powers in React. Yeah, I mean, and also I feel like Angular spent a lot of time fixing very specific problems that would fit their real needs. Sometimes React's solutions seem kind of heady, like kind of academic. And to be fair, I'm in an interesting place because with Solid 2.0, like at a certain point, you sit there and you bash enough bugs all over the place and like see these patterns emerge, and you're like, the solution does actually need to happen at that level, right? The level at which React kind of tends to operate at. It doesn't mean you should like change to just doing what React does, but you have to like step back and be like, look, is there a systematic problem here? Is it our fault, right? Almost every major framework change in the last like 5 or 6, 7 years has been around that. Back in the day, it was originally just like pure DX play. But now new frameworks now have been mostly coming out of like, is it our fault thing, and being like saying yes. Like Quick was like saying like, is hydration being slow, so like that piece our fault? And Quick's like, it's not the developer's fault. It's definitely the framework's fault. That's their premise. Solid's perspective was, is the UI getting updated slowly or like not as efficiently as possible on like weird like kind of like re-renders and all this kind of like obscure kind of weird mental model pieces the developer's fault? And it was like, no, it's the framework's fault. Like I feel like that has been kind of like the sign here. Originally it was just like I don't want to write jQuery anymore, but then it's evolved into like us recognizing that the abstraction or the tool should be providing something that it doesn't currently. Why do you hate web components so much? Okay, I mean, I can answer this actually pretty simply. Because they actually aren't that much of a problem in a certain sense. You could say that they're just extra. They're just like an option. And if they were just an option, I'd be like, okay, the problem with web components and why I have so much thing is they're unnecessary, and then their existence influences other decisions. So it makes it a very awkward place to be, because basically we tagged on something that arguably is optional and then tried to base everything else off their existence in a way that like overcomplicates and undermines the ability to do things in the most simple, direct, and performant way. So it's like on the surface, as someone who using these APIs could be like, okay, well, you don't have to use web components. I can just use web components. In principle, cool, go for it. But like the reality is the impact of their very existence makes everything else worse. So I think I could even be okay with that, except for like web component people keep on coming around and being like, hey, why don't you do this or do this with web components? And it's like, if you knew what you were doing, you wouldn't even ask that question. It's like, yeah, sure, go ahead, do that with the web components, but why would I have to worry about that? Because like they don't add any value. Like it's less like, do you know what I mean? Like it's like it's a combination of like their impact on the platform and the fact that like people seem to be like really wanting to push them when like it almost like not understanding what they do. And it's kind of like you have to like repeatedly be like, okay, well, sure, like you can go do that with your web components. You don't have to do anything in solid to do that. We support web components. We've taken that hit, but it's like, it's like I have to. It feels bad after a while being the one to have to deflate people's expectations around web components, right? You almost get kind of like annoyed or frustrated with the people pushing them because it feels like they're selling a lie or something like that. That's usually the challenge there. The technology in a sense could just speak for itself, but there's a lot of misconceptions around them. And it's not that I don't think that they're incapable of doing things. It's just like it's one of those things where it's like, yes, you can do this with web components, but then like you can also do this without web components, and it's arguably better. So why are you conflating web components with this thing? So you don't hate web components, you hate the culture around it? Um, I don't have the same conflict with React or that. I think the thing is React knows exactly what it's doing. I mean, maybe not all of its fans, but React actually generally is fairly straightforward. Like it's very clear to me at least what the trade-offs and the design decisions are and how that flows. It doesn't feel ever like it's dishonest. Anyway, what does any of this have to do with anything? Well, React's ivory tower and oversimplistic design gets us to certain places much sooner than others would have got to, because most of us were just building apps and just trying to build things. And if we hit a few awkwardnesses, we're just like, do we have the tools to deal with them? Yeah, we do. That's the pragmatic approach, right? You kind of like figure out where the lines are. I think there's a Ryan Florence tweet that we covered a couple weeks ago that was like this. And then honestly, you just when you have to ship, you just fill in you fill in those gaps with whatever crap you have available and you move on. I mean, AI works the same way. You just kind of move forward to it. At a certain point, though, you have to really ask about like where those lines are drawn. And in React's case, there's like two really, really big reactisms that piss people off a ton. And I think it's important to look at why they exist. One of them is the set state and then state not committed one. And the other one is the fact that they have these dependency arrays. Now, the set state and state after one wasn't always a clear picture in like React 0.13 or 0.14, like 0.14, 0.13. There were cases where you could read the next state, and eventually point they were just like, no, stop doing that. We need to make this we need this like settle on this one behavior. This one is funny because I'm calling out effects particularly because you don't need the reason that effects are special here is because technically the side effects should happen independent of the rendering. Like dependency arrays on your use memo or use callback or whatever like other mechanisms you're using in React aren't necessarily important because you know that that code's all going to run during render. It's basically part of the render pure part. So the mechanical need for dependencies might, be seen as a shortcut. But for effects, you do need to know the dependencies before you run any effects, because those dependencies, like you need to make sure that all the effects run at the same time. If you run some effects and then you get interrupted or something can't go and you run other effects, you end up with torn UI. So you have to make sure that you know all the dependencies up front. And Signals libraries kind of got away with not necessarily doing this because you can kind of ask for the data wherever you need it. So they're just kind of like, okay, well, we'll just create effect, whatever, read the stuff, and then it could, you'll just get it. And who cares if like we process some of the pure calculations late, if it's a lazy pull system, or if we, do some part of an effect and then do some other stuff and then do some other effect and do this and kind of isolate it across, because there was no possible way, because everything is synchronous, for any of those interruptions to escape that render frame. Like you knew for sure that, some stuff might kind of flitter around a bit, but in the end, you're going to end up with, in the same tick, you're going to end up with a consistent UI. And I think once you understand like these kind of two fundamental things don't hold up during async, you're posed with a very kind of interesting question. And I think this is why I want to talk about this. And I'm talking about this like physics, because this is kind of a fundamental truth. I'm very open to people in chat arguing with me, saying why both of these things in React are terrible. But try to argue that these aren't necessary is a much harder task. Is your latest YouTube video a good introduction? Not really. My what React developers should know about signals is a good introduction to React developers who at least know like what a signal is, and then they've been hearing all this bad stuff about it. It's mostly myth busting. I don't have a great like intro to signals video in the same way that I have an intro to signals articles. But even my articles, like how to build a signals system, depending on what level of what you're looking for, you might find it better elsewhere. An only thing a program with effects can do is heat up your CPU. Yes. And a lot of the stuff that we're going to talk about today in terms of physics is kind of understanding this, like, if a tree falls in the woods and no one's there to listen, like, did it make a sound? Like, that is part of what we'll be talking about today. React's biggest gotcha for me personally is that useState doesn't update when you source it from a prop, and prop changes later use effect. Yeah, almost everyone does this. This is why Solid 2.0 directly addresses this. I also want to talk about why Solid 2.0's design is better than dependency arrays, even though it feels like dependency arrays. This is a problem not unique to React at all. And I came to the same conclusion about 3 or 4 years ago when I started working on Solid 2.0 designs, when I realized that this was like the biggest source of people needing synchronization, is that when you construct the graph, you can't create the dependency through state, which is kind of crazy because React re-renders. Almost everything about React makes you think that like you would. Like, oh, if the props change coming in, I should be able to reset my state. And the answer is you actually have to create a side effect to do it. Now, you can key the component, but that's such a brute force way of doing it. The other thing is you can derive your actual state from your local state and the props, and then kind of like calculate it inline. That will also work. But these are very like complicated ways to do things that are very clearly trying to set up a graph like dependency change in a re-render model. I just said it's not unique to React at all, but it feels like at a certain point I was like, this is the gap. Yeah, I mean, I don't know if you've seen Solid 2.0, but that's exactly what we did. You're in the stream, you definitely know what I'm talking about, right? In React, when you have useState and you pass a function to it, it's a safety guard for when you have work to do. If you want to know what I mean, for people who, sorry, not Excalibur, I'll just use Solid Playground for explanation here. We actually use this trick on Ricky's stream, but essentially, like when you do use state in a React component and you have something like expensive. First of all, if you could do use state 0 and your component reruns, because I'm gonna call it count. count set count. Let's choose this because you might have moved count, like did an event and set it to 3 or 4 or whatever, because you have to persist this state in React. When like the component reruns, it doesn't reset it back to 0. It keeps whatever the count is. It makes sense. But the problem is if you have like expensive calculation is how your thing, it would be, the problem is because this code actually runs, even though it returns back out like a cached value out of here, because this reruns every time, you wouldn't want to do that. So React gives you the ability to pass a function in, but the function only runs initially. Essentially, it's just a way of guarding. So it's like, look, if someone passes a function into use state, don't rerun this expensive calculation. Keep the cached values. Only run this initially. So it doesn't solve the problem, right? Whereas if you have create signal, your components aren't rerunning. And for that reason, this behavior is implicit because it will never rerun. So it will never run this out again. So the fact that this updates is fine. You'll never have to worry about it, which lets us overload this now. Like basically this would be perfectly fine because the component only runs once. But it means we can do this too, and have the function, like most things in a signals library, mean that it actually reruns. So whenever the props change, you can reset. So this behavior of deriving state, which is very natural, is something that we can do very naturally in this model. Yes. Yes, exactly. You want to reset. This happens a ton in forms, and what most people do is they put use effect in. The better solution is to the things that get allocated and throw away immediately tend to have way less of a memory impact than you'd expect. I've found. But yes, this is a source, and it's a little bit off topic today, but it's a key place to kind of show like how you can adhere to the same sort of physical rules, but by slight adjustment in the execution model, not be subject to the same downsides. Okay, so with something like this, all like 70, no, I'd say 80% of state synchronization bugs, or sorry, needs for effects go away right off the bat, because suddenly you're not like writing, like there's so much wrong with doing this, right? Use effect. Sorry, let's go back even further. I want to go back to the degree. Yeah, there's so much wrong with doing this. Now props dot value depends on props dot value. Cause like it's actually telling the component to rerun again right off the bat, like because it runs, sees a state, uses the effect. Now the effect doesn't run until afterwards, so it goes through, renders with count being 0. It's possible that if it sees this no, actually wouldn't even know even with that invalidation. It renders with count being 0, and then it cycles through and renders again. You've never had to do this with, you're telling me you've never done what's in front of me in React. I feel like you hit this problem within the first 2 hours of using React. Like every developer has hit this problem. You've never used use effect to synchronize state. sorry, I'm like, whenever you see those horror examples on Twitter with forums and all that, it almost always boils down to someone doing something like this. Like, React had to write a whole doc section specifically on avoiding this pattern because it's literally what everyone does. Yeah, people do it now, but this is like this is like the dumb pattern. Everyone, I don't know if React ever suggested this was a good pattern. We have UI live management, lots of fun. We have tons of this. Yeah, like this is the problem is this is a very common shape. It's called the ephemeral override state, like scenario. Like this is like what is a good pattern in React? Sure, two things. The easiest pattern for this in React is this. Let's do value so we can see it. The easiest pattern for this in React is that when you call this component, you do this, key props.value. If you do this, every time value changes, the whole component's going to reset, which means it's going to create new state hooks, which means it's going to get the latest value. Right, like it's basically going to throw away all your previous state and reset it this way. This way you don't need synchronization. Now, obviously, if you have multiple of these, and then you have to come up with like an interesting, like if key or value, like, I mean, I guess you'd be fine with it over re-rendering, but you know, get all your depths in here, so to speak. You know, I guess if I made this an array, that would be awkward because then the array would be a new instance every time. But you can basically create your dependency array for your effect in your key prop. Really? I'd be interested at some point to hear how Phi broke your brain. I mean, unless it's like what I've been talking with the async stuff, which I think is breaking everyone's brain. I understand this thing. I just don't see reason to store a prop value in use state. Okay, picture this. I mean, the example with forms is really easy. I have an input, right? Actually, I deleted too much. Function input. Okay. So now it is an input component. Okay. Input component. Okay. And our input component is going to wrap an actual native input. Okay. Now, we want some sort of way of this component saying what its value is, but I mean, it's going to be a complicated input. It's going to have like other functionality in here, which is why you wrapped in a component. But we also want the ability to manage it in here. So like, essentially, we don't want to save. We don't want to do like this. Like, we don't want to like input might not be because it has immediate feedback, but like some kind of component, like on save or something. Like we don't actually want to pass our information back until we commit it. Like let's pretend our input has a button to save instead of like instant typing. So our input basically wraps like you have to press enter to commit the value. So there's this temporary state that essentially gets initialized from here, but does not get communicated back up here to get pushed back down. It actually stays inside the component while you're editing it. And then when you press like enter or on save, it actually communicates the information back up. So in this scenario, if the input ever coming in changed, you need to actually reset this count, but you also want to have a temporal override until you're ready to communicate the change back up. It's just like a temporary state. I use an input here, but basically the idea is that you have some kind of like temporary like scratch pad that doesn't impact the rest of the system. It just lives locally, right? In this kind of scenario, you're going to need to initialize it with this, but then you're also going to like, maybe there's a button in here too. I mean, I'm just making stuff up here, but then like on click, this calls on save, right? So at the end, when you click on save, it will hopefully, we'll do something like, value, you'll probably set it to like set my count to value, and then my count or whatever like is here. Like you'll close the loop, but generally speaking, this has to be, even though it's derived from this, it needs to it needs to have its own temporal override. And as I said, this pattern is relatively common. Forms are where you see this like a billion times, but it also happens in other situations, like just like places where you need to isolate changes from the global store, or like places where you like any place where you do some kind of speculative change, and it doesn't have to be like over the course of like a specific life cycle, right? We're not talking about like optimistic updates necessarily. We're talking about like something that could persist a while. Sometimes errors are another example of kind of like a speculative kind of override, where the life cycle isn't necessarily tied to either the action itself or to the persistence in the store. It's, these kind of patterns naturally emerge. No, that's what I was getting at. With key, you'd have to like somehow register them all, and any of them would actually cause a change potentially. If you, I don't need to go too far, but it's like React docs have a whole page on this. When not to use effect. You might not need an effect. Beautiful. These docs are worth reading for every single person in any framework, but it's very React specific. But I think this is important. React key is such a hacky solution. Yeah, I don't like it, but I understand because it's often the simplest. Like the example is literally what I talked about. Like this example here, the obvious answer is you should just derive it. Like this is a use memo case. You don't need to like make it a separate state for full name set name. But what if it's writable? Then you actually, well, see the if you can calculate it during rendering, this is better, right? But sometimes you need it to state set a little thing. Like they have a ton of examples in here. This like React knows this is an issue, which is why they have quite an extensive thing, right? Post request. Like this is so common. Where's the key example? It should be. Yeah, here's the key example. This is the general better approach, where you like, but even because what this can do is React smart enough that if you invalidate its own state in the course of rendering the component, because this component here is like the state is part of the same component. It goes, oh, when it go before it like renders the component and the JSX structure, like the virtual DOM, but then before it actually tries to realize it or reconcile it, it goes, in the process of this, we became invalid again. Don't continue. Don't go on to the diffing and patching stage. Rerun this component with the updated state again. So it's more effective. If you use effect, unfortunately, you actually cause a full render cycle where it actually does do the diffing and patching and then comes back around again. So this is better to do inline writes during the course of this. But I mean, this is also kind of weird because it does cause the component to re-render again. But because the component is the only, how should I put it? Because the component is the only unit of reactivity that React has, it actually, like, it doesn't have many choices here. Rerunning the component is better than running the render cycle. Most of this article is just David's. Yeah, David from XState made this thing. Anyways, I'm not here to necessarily solve React's problems for you. This one is solvable. And I showed you how we solve that with Solid 2.0. Very simple. You just derive the state. Done. Whole class of use effect just goes away. But these two problems are trickier. No, it's actually it actually stays working like create memo. The reactive update overrides your local setters. The idea is that the derived value is the override. So you derive it initially, you can override it, and then it can always be reset by the derived state coming in, which is what exactly you want in all of those use cases. Now, you could be like, well, what if I want it only to initially work reactively and then just override it? Well, I mean, in that case, you didn't need any of this mechanism. You could have just like untracked the read or just like set the value. Like that's the default because our components don't rerun, right? Like the default is like the default for all frameworks or like React is this. It's like it's derived initially and then you override it. And so the hard part is actually making the override or making it reset the override, right? So I want to talk about both of these because these are controversial because these are arguably the things that people love most about Signals and hate the most about React. I can just auto track anything. I don't have to this delayed commit because I can literally just ask for the signal or the derived signal or anything down the chain afterwards and get the answer right away. And the problem with async is those two things are no longer true. So let's start with probably the most controversial truth, even though it's the least deniable one, right? No one can argue with this first flush one, and I'll kind of explain a bit why. Okay, now this whole thing is just explaining just async. We can talk about that in a minute if we have to, but I want to talk about this commits thing first, right? I've covered this so many times in the past, but I wrote an article a while ago. Probably worth it. I was really struggling around the time Solid 1.5 with this. Sorry, is it possible to reset a derived signal to its derived value after updating it? I mean, that's what it would be doing, right? It reruns the memo and then that's what it ends up with. So this is an old experiment that I did where I was showing this React example where I had state, derived state, and then a DOM element. And I was like, after I set count, what the hell do we get if we log all three of these? So this is just a counter. Oh, we actually have that. It's called refresh in Solid 2.0. So yes, you could do that if you wanted to, but the primary way of doing that is actually just updating the reactive props. No, like you don't even have to set signal. You can literally just tell the computed to run again. right? Usually it will automatically run because the props change. But if the props didn't change and you want to do a reset, we have this specific mechanism. It's very useful for async, but it could be useful in this case where you're just like, hey, like reset it to like just rerun the computation again. Or in the case of async, refetch this again, like for invalidation. So yes, we do have this mechanism. The big thing is like having extraneous set values are kind of the things that I kind of want to avoid. I think like when I think it's a lot cleaner to think about it like I need to reset this computation rather than like have to like write it back. Do you know what I mean? Like, because like there's more truth in like talking about the derivation of it than like just being like, okay, in this condition, then write this, and because I know that this is what the source is, then it'll be fine. I mean, you can do that, but that's not like as clean. Yeah, async refresh is literally rerun this computation. Yeah. Truthfully, the value shouldn't have changed in most cases, but here's another. But yeah. Yeah. So but the reason I showed this is because this I was working on Marco, we discovered this, and then we realized that every framework logged something different. React logged 000, Vue logged 120, Svelte 3 or 4 logged 100, and Solid was 122. And if you look at this in the abstract, only React and Solid are correct, arguably, because they're the only ones that are consistent. Like 0, if count is 0, then double count is 0, and then the DOM is 0. Consistent. If you look at Solid, also consistent. If count is 1, double count is 2, and 2, it's 0. Svelte mimics JavaScript things, because if you update count, then double count and current count couldn't be updated. So like it makes sense from a JavaScript thing because the stuff hasn't happened, but it is an inconsistent view. Like you're like arguably I'd argue you shouldn't be reading after you set the count, but it is there's like it's hard to argue with this expectation because it like in a synchronous frame it makes sense. And then Vue was kind of like, we'll do the reactive stuff but not the DOM stuff. Now the truth is, at the end of this article, I was like, maybe Svelte is just right. Because and the only reason I said this was because I'm like, React is so painful. No one likes React. This is great, but it can be bad for performance. Solid's granular, so like you can get away with doing this, but like fundamentally speaking, like as a general solution, if you do like 10 updates, you probably don't want to render 10 times. Sure, each update is pinpoint, but there's going to be cases where that's not the case. So as a default, this is like putting a little bit more on the user to be like smart about performance, and like this, like it's okay. I don't hate it, but it maybe not amazing. This one everyone hates. This one I can at least explain, even if it's like less than ideal. And this one is like this kind of magical happy place, but also maybe a lie. In the end, what ended up happening is everybody just ended up going to Vue, more or less. Solid is still on this right now, unless you call batch explicitly. But generally, my plan for Solid 2.0 was this. My Svelte 5 is this. And that's how we were all going to be here with Vue, and React was going to be by itself. That was the plan for Solid 2.0, like 4 or 5 years ago. In the last year, and arguably in the last 6 months, I've just realized that React's version is probably the only correct version here, which is a really tough pill to swallow. Yes. Because the problem with these models is one is doable. Svelte is doable, but it's a little bit misleading. I could argue for this approach still, like I did in this article, but the problem with async is you don't know necessarily what is async when you're just like sitting here reading these values. Sorry, I don't need to go back to the original tweet. Right, when you're sitting here reading these values here, like in this event handler, like sure, the async stuff is defined over here, but here you're just like, I'm getting count, double count. Like you aren't aware of this, and this could be in your UI under different conditions of loading. You want what you're dealing with here to reflect what your user is actually seeing. So like, let me go back to the article here, and basically the same example. I didn't put the DOM in because the question of when the DOM flushes is a question, but it kind of falls out of the other two, right? Like the reality is the actual question is what double count should show and what count should show, right? If you go back to this example here and you kind of crunch it down in, if you ignore the DOM, view and solid are the same. And then, and if you go to Svelte 5 now, actually we're all the same except for React, right? So that's why we're able to kind of do this compression. I'm not going to worry about the DOM. If you're React, clearly the DOM hasn't updated. And if you're the others, the DOM may or may have not updated, but that is secondary to the actual concern here, right? Hopefully everyone's still with me. So right, in plain JavaScript, count and double count drift apart. Signals fix this by updating double count on read. But this still leaves the question, when does this update? The DOM just did that. Okay, React was the only system that didn't update count immediately and people hated it. But the motivation was sound. React wanted event handlers to see consistency and they had no way to update derived values until the component reran, right? It's like the Svelte example. Like React has the same conditions. Like old Svelte wasn't signals. It was basically like React. It wasn't a virtual DOM, but like even Dominic from the Svelte team called Svelte 3 basically a virtual DOM. Like conceptually, it had the same component rerun model. It just was heavily memoized. It was almost like the React compiler. That's kind of like how Svelte 3 was. So the thing is, when you look at the JavaScript of this, how could double count or the element have actually updated when you just set the count? It's not possible with old Svelte, and it's not possible with React. So you have the choice: either update the count immediately, which made sense for Svelte because they make it look like it's an assignment. They hide the set count thing. It's hidden behind like the compiler. So them not updating one seemed really weird, right? So the move from Svelte 3 to Svelte 5 was them being able to now do this, which made their story much more consistent. But this was kind of, all they could do before. React was like, no, we want to show consistent value. That was the only choice here. React could not make this value 2, even if it wanted to. Neither could Svelte 3. Signals let you make this value 2 if you want it to be. The question is, should it be 2? And you'd be like, obviously. But actually the answer is not obviously. It's actually probably no. Calling flush occasionally is better than having to do batch. I agree completely, which is why views kind of timing is what's kind of been where everyone kind of landed on, except for React and now except for Solid. Let me explain why. Now, obviously, if we looked at books.length directly, we could avoid this. But my point here is I wanted to show an example where you have some derived value, like length is easy to derive, but how about something more expensive, something that isn't as direct? You have some derived value and you're basically nulling out the source, right? If you null out the source and you haven't updated the derived value and you use that to interact with that source, like you're going to end up out of bounds or reading undefined or crashing your app probably, right? This is why I never liked Svelte's model. React, I felt like if you can't update the second value, you shouldn't be updating count, right? Like if you have no way of making double count updated, you shouldn't be updating count because this will happen to you. You will cause your program to crash if you put expectations on double count. Now, you can know that to avoid it, but it's not consistent, right? Like you understand here. Books length is 5. You set it to an empty list. This hasn't updated. You go books 5 minus 1 is 4. You read books 4 and there's nothing there. Maybe you read a property off it. Oh, guess what? You've thrown an error. Like this is Now, frameworks that do this have like tick or await, but to force the flush, right? But it's kind of like, and this is important to put in the other article. Every framework has an ability to mimic those other behaviors if they want to, but it's the question is like, as a default, should every time you set something cause you to call flush? Well, maybe you do want to read these values, so then the answer is yes. But if you don't call flush, should it break? And I think React's approach is a sane one, which is if you set books here, books is still 5. So when you pull out this book, you're actually seeing the book listing at 4. Now, should you write your code this way? Probably not. Right. The whole read after write is just like a bad smell that you shouldn't be doing. The problem is that with signals libraries, we let people feel like they could do this. We were like, yeah, go for it. We don't care. It was never a good thing to do, but we made it feel like it was okay. Yes, right. In Vue case, you never need to call flush unless you read from the DOM. But there's a problem here. And reading from the DOM is pretty rare. Well, yeah, and you can conceptually be like, yeah, I need to read from the DOM. I'll call flush myself. Like it's an easy. It's easy to get there. You can go like, it's not like normal logic. Don't need it. I only need to call flush when I need the read DOM. Will reading still signal throw? It depends. It doesn't have to throw if it has a value. If it doesn't have a value, then it would have to throw. But if it has a value, it does not have to throw, right? Like, as I said, like in React's case, reading books.length being still 5 or whatever isn't going to throw, right? So what does this have to do with async? Well, we don't know if books.length has updated it or not. You could write all your code like this, right? Write all your code, be like, I am synchronous, everything is up to date, I'm using signals, don't have to worry about the stupid reactism. And then someone realizes that this derived value, books.length, actually needs to be calculated from something on the server. And suddenly, you've produced this problem because this updates right away and you're like, sweet, empty, and here it's 5, it's out, and it throws. And it's not where you declared your async work. It's not happening in here. It's happening in the event handler. It's happening other places, because that async work might not even be in the same component. You've basically broken the graph, and you've basically, because you depended on this behavior, potentially have now crash errors all throughout your application. Only a problem with colors things to do. Well, no. This is a problem. This problem is not with color, because all async becomes colorless once you pull it into the system. At a certain point, you have to consume it, right? I will say that the other problem we can talk about it where colorless async makes it trickier. This is like, if this was felt and I put a weight count number 2 here, double count, like this isn't colorless async. I mean, double count, like derived, if this is derived, a weight count times 2 or whatever. If I did this here, it's not colorless async in the same sense because I needed to pass promises through in that. But as soon as I realize that value, I can't get it right away. There's no way to get double count from count synchronously. So this is not a colorless async problem. It's a realized value problem. At some point, you're gonna have to convert the promise into a signal, and if anything, or into like a value, and anything downstream of that suffers from this. That's not colorless async in the same way I'm talking. Like the reason that we talk about colorless async in Solid is because it's 2.0. It's because we really pushed that consumption point all the way to the top. It's where it enters the graph, and then we actually propagate it through all the reads. So we get to this like very cool, consistent system where like and I could probably draw it out for you, but where we can actually push the blocking all the way to the leaves while you can actually do the consumption at the top. It's actually really powerful. But even in a system that doesn't do that, makes you explicitly pass promises around, at some point you're going to eat the promise and bring it into your system. And at that point, you are no longer looking at the promise. You are looking at a signal or a value. It will happen somewhere in the graph, and anything downstream of that has this problem. It's fundamental. Yeah, right. Okay, so, okay, you can solve this by, yeah, okay. I see what you're saying. What you're saying is like, never consume it. Right, but what I'm pointing out is like, so yeah, okay, but you're gonna have to consume it to get it into your rendering system. I could say like, okay, yeah, well, fine, we should await books.length. So instead of breaking it now, what will happen is, I mean, you're still gonna have a challenge because you can now have to go all through your app through all the places where books.length is and go, okay, actually books.length is a promise. Hopefully your TS is going to complain because when you try and do books.length -1 here, it's going to be like promise is not a number. So then you know exactly where to fix. But as I said, it still doesn't change the fact that at a certain point you're going to actually consume it. You're actually going to use the value, right? You can push it down to the leaves as much as you want if possible, but there is something very fundamental about this. Right, but you understand, like, we're in an event handler. Are you suggesting that when we get into our component body, we should fork it so that there's a consumable version that we can just stick directly in our UI and then a version that we can await separately in our event handler? Like, let's be practical here. As I said, I've built this exact example in Svelte and seen this exact behavior, which is why I'm aware of it. I did an await derived, right? I think as I said, generally the Svelte model is in the right direction. I'm just saying, like, there's a certain truth here you have to address here, that there is going to be a point, unless you really fork the paths down to every last read point here, you're going to at some point absorb the async into your graph, and behind that graph you are going to break consistency if you flush the value immediately. Like, as I said, we can think of ways of how you can avoid it, like you're saying, but this is physics. This is undeniable truth. And the funny thing is, if we did do this, like make double count async in the Svelte example, it would show the consistent UI. Like, it would show like in the UI here, we would see 1 times 2 equals 2, then 2 times 2 equals 4. Like, it won't update. It will actually hold the UI properly. But in your event handler in here, you will see 2 times 2 equals 2, so to speak. So you will break in exactly the way that I'm talking about. I'm not doing this necessarily to poke at Svelte. Svelte's solution is much more advanced and much better than 99% of the solutions out there. But this is like, this isn't like you're that's an option, but events are how should I put it? Events are side effectful, so it's kind of dangerous to rerun events. You wouldn't want that as a default behavior. I can understand why you're concerned. I'm just saying is you're not going to avoid this in a signal system. Even if you pretend like your async isn't colorless, once you absorb it, you've created colorless async. Now, you don't need to worry about it a ton in certain scenarios. But the reality is you block the graph. You can't not block with async. So if you block the graph, there's going to be part that is blocked and unblocked. This is, I said, the reason why something like Svelte will still give you the exact proper output in the UI. They know you block the graph. They're smart enough to handle that. Or why? I'm. You guys are gonna force me to make the Svelte example just to show you what I'm talking about, aren't you? Like, sorry. Like, to me, this is so obvious. Like, but it's because I've been looking at this for such a long time. You have to. You can. Okay. The one way around it, I suppose, is you can choose never to consume it. Like, from a practical standpoint, you're probably going to do a calculation at some time, or like do a compute it or something to consume it. Like, the only way you avoid it is if, as you said, you literally don't do double count like this. You literally await in here, and maybe that's the answer. You never do an async derive, like basically await. Like, you literally have to push the await to every single call point, which means that every derivation, everything you calculate off it, it has to go through like a then promise chain instead of like being able to just do something nice like count times 2 or double count 3 or format username to type. You have to force the whole chain through thenables and be very rigid to never resolve early. Or yes, this whole category goes away. The reason I'm bringing this up is because so many of these issues are based on like basically this kind of problem. Like, think about it. If you built a system like React where it doesn't update after you call it, like you don't see it updated, are you going to read stuff afterwards in event handlers and setting state? Nope. You're not going to do it. Like React talks about pit of success. 000 is pit of success if you think about it, because why? If you know the value is never going to update there, why would you read it afterwards? If you actually want to update it, what you're going to do is you're going to take the value updated and use that further down in your calculation, right? You're going to be like, instead of using book's length or whatever, or even read books, you're just going to take this. You could be like new books and then go new books.length and this, and you're not going to read reactively afterwards. So React's API design actually guides you to do the right thing. It's so funny. Like, we're fighting this so hard when the answer is like kind of obvious, right? We have a real physical constraint, something that we can try and work or hack around, but it's the wrong mindset to view these events as being inside the system. We have a synchronous system with events and side effects spinning out of them around it. If you view those as truly external to the system, you can preserve the integrity of the system. React hit here, obviously, because they had components, and there's inside and outside the component means very, very different things. But the shape of the problem is real. Yeah. Yeah, and to be fair, when we were working Marco, we went even harder. I don't know if Marco 6 landed here, but we were like, I don't want to think about this. If someone tries to do this, just throw. We were just like, just error, right? Which is like the really like nuclear option here. But the other option, and maybe like, you know, maybe that's sane, but the other option is React's option is still very, very consistent. Like I get it why people are fighting this so much because this is a big departure, but it's you the the experience of what you have to force in order to get here and the impact of these changes in order to get here seems an incredibly extreme versus the simple truth of this, like, don't do this. No, I'm not saying this has nothing to do with performance. This has to do with correctness. Um, I'm not quite sure what this has to do with. Are you just talking like threading consistency model? I mean, I don't think that's the case now. We have solutions with signals, arguably, which are not just vanilla JS things. We have ways to force consistency that way. The problem is these models fall apart under async pressure. Can you throw it to DOM vendor? No. Why? Why? What are we throwing? Also, I think it's also something reacting that people are probably, yeah. Like the funny thing is, the stream is like so hardcore on this stuff, and it's really hard for reactive people to kind of stomach. But if I show this stuff to Tanner, for example, he's just like, yeah, so what? And you're telling me I just solve all of React's problems, and this is the cost? It's like a no-brainer. You know what I mean? He's like, React already has this, and this is actually not even as constrained. Like it just seems like, you know what I mean? Like, yes, yeah, but that's what signals are. But I'm saying that doesn't actually solve it. You can't have a value you don't have yet. As Robbie pointed out earlier, your only way out of this is make people await here. Like, but it means that you're not consuming the promises ever, basically. Like you need to make sure that everything is a promise. Like you're running with two systems, a promise system and a signal system, which um could be okay, arguably. Um but it's like even Svelte doesn't force you that hard down that line. React doesn't. React has use. There's always a consumption point because at a certain point people are trying to write synchronous UI and declarative things to make it easier. They're not hoping to write yields and awaits sprinkled through every single part of their code. No, I don't think this stuff has to be costly. What I'm talking about is completely consistent. It has nothing to do with performance. It's about consistency. I don't see anything particularly expensive here. This is just like truth. It's not about performance. It's literally about consistency. So this isn't like something for AI to solve. This is not a like. Can AI solve gravity? We can build better planes, but like, you know what I mean? Like, we're talking about physics. So Svelte's a great example here because Svelte actually does all the right stuff in the UI. Well, mostly, for the most part, all the right stuff in the UI. But it's still because of the fact that their variables are like this that they still keep their original model here. I'm just saying, like, and I don't even think it's a big deal because as we all said, just don't do this. But in 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 reality, when talking about the whole thing, like, so basically Svelte does most of this. It just, they have this one inconsistency in their event handlers, which probably you shouldn't do anyways. But generally, there's this truth here, right? Like, we hit this when we were doing like transitions in Solid 1.0 as well, like where like inside transitions, Solid worked like React. Like you'd do the write, and then outside you wouldn't see the stuff until the transition ended. It's just fundamentally, to be consistent, it has to work that way because you're showing the user something. If they're interacting with it, they should be interacting with what they see, not some future state that doesn't exist yet. They have special stealth events. Have I missed that? I try and keep up on stuff. I don't know what that is. And I don't think looking special stealth events is going to find me on a query. I'm just saying this is, while you can ease up this constraint if you want to, in small ways, it's hard to argue that React is not the only solution here that is completely correct. It's arguably the most correct and honest approach, right? Like we can like pretend it's otherwise, and it will probably come to bite us later. But even if we can, this is the reality I had to face. I realized like I could do this. I could like force the reactivity through. I could make it so that this was updated, but in some cases, but it's kind of a lie. It's a convenient lie, but the problem with convenient lies are they will catch up with you. Like, I'm only thinking about the design space I understand right now. If you move to the future, you don't even know what kind of problems you're going to hit. So like, you kind of, it's usually better to err on the side of doing the consistent, honest thing than lying, unless you are completely sure you can get away with lying. I know it's not something we love. Um, Dependency effects must be known at computation time. Now, this is true. The Yeah, yeah, but that's not solving it. Sorry. If I haven't made it clear enough, because people read this article and they're like, "Oh yeah, view handle." No, it doesn't. You can solve all of these using explicit APIs if you know to do that and guard them, right? As I said, I said this in the other article. Like, if you can use await tick or next tick in await tick in Svelte, next tick in Vue. I think this might be a settled thing now in Svelte too. In Solid 1.0, you could get React's behavior originally by calling it in batch. Later, that was just a way to get Vue's behavior. You can, like in React, you can use the callbacks on the setters as a mechanism to get something similar to Vue's behavior. Like all the frameworks have escape hatches for the other behavior if you know to. The problem is if you start in one state, you don't know to change it. Like, it's not about like being able to do a wait next tick. It's the fact that you change your code somewhere and now you need to do a wait next tick in like 10 different places you didn't realize. I don't even know if I should read this one out loud. It's funny. The obvious solution is using Remix 3. That's funny. Um, so sorry, what is Felt's event delegation managing for here? It delays running events while things are held, but then it wouldn't even be showing them. So I don't. Yeah, I'm not quite sure what. I like. I've definitely reproduced this bug in Svelte. like 100%. It's felt 5. I mean, I get you're kind of asking the remix question. I get why people are thinking remix. I don't know. My gut here is that Remix has changed their approach. I don't know what Remix 3 is right now, but the version of Remix that they showed at the unveil, I am very much in the camp that that approach is not the way things need to head. I think they've refined stuff since then, but I don't know. We won't know until they reveal it, so it's hard to say. But if you're talking about the Remix as they presented it a few months ago, then even it doesn't matter if AI can generate plain JS code, because the problem is plain JS code doesn't have all the edge cases encoded into it, right? Next thing you know, you're like, we did this on stream a couple of weeks ago. You're like managing a bunch of extra states. Sure, they're not framework states, but they are effectively different states that you're writing to manage like the life cycles. And because they're not framework states, you're the one responsible for calling update. Who cares? Your code is vanilla JS, but you didn't take into consideration all the edge cases, and now you're talking about things like abort signals and stuff that could just be handled automatically from the shape of the graph, but instead you're manually managing this stuff. Yeah, I mean, you can create a debounce signal. Staplets. You can almost view do you guys remember the Sierpinski's triangle problem that reacted that proved concurrent rendering? You can almost view this as a form of that. Because we keep our effects guarantees, we can debounce heavy work without impacting the rendering at all here. Because in a sense, how did I solve this terribly expensive thing? I just made a memo, request an idle callback to propagate its thing. So there's no effect here. It's just an async derived value. So I'm kind of basically leaving it up to the browser to schedule it. And because this still participates as part of our graph, all the numbers update at the same time, even though this is a hierarchical flush out. Like essentially, like now, if you want to detach from the graph, then you need to do a little bit more work. But that's like opt-in Terran, something that you want to do. Like what this is basically doing is like if I didn't have this promise and I just returned seconds, then things get really bogged up here, I think. If maybe, sorry. Oh, I have to actually put the freaking fake timeout in. Sorry. Let's, before we return seconds, let's put let's put the work in. Okay, now we're freezing up the graph while we're moving because we're doing this expensive work that's blocking. See, we're making sure that our UI is consistent, but like, look, even the hover state gets frozen. Ooh, oh, let me get it. Let me get the yellow away from my mouse. But we can just inject async into the graph here. And now everything is smooth, even though it's doing stuff that basically takes the whole second to calculate. Anyways. You could, if you break out a synchronous flow, you can, and you would have to make it colorful, like in a way that even Svelte doesn't make it colorful. You literally have to like pretend that like you'd have to pass promises all the way down and never consume them by the framework. And in that world, but then the framework wouldn't be aware of, like, you would be I mean, you'd be where things are today in most things. You'd be responsible for consistency. No, even then, like, how do you how do you make sure that one, like when it's 0, that it doesn't show 1? Like you'd have to micro schedule everything. So like practically, I don't think so. That's the whole point of the video is not very ergonomic. You color based on what might suspend versus instead of using promises. Yeah, you can maybe like I saw a really cool library this week. It was called Lazy Promises, where someone basically fixed all the problems with promises in libraries and wrapped the promise primitive. But it still involved like basically abstracting something like a promise, like an async primitive, that was independent of the rest of the reactive signals kind of graph. Which, as I said, it's a direction, but it also doesn't give. It's like the opposite bet. It doesn't give you that. It's the opposite of the bet that React and Svelte and Solid are currently taking, which it doesn't give you this orchestration control. The orchestration control is really, really valuable because it lets us write our intent in a clear way while coming up with reasonable rules to isolate change, which means that you don't have to worry about what something else is doing over here versus what it's doing over here, which is very valuable in this age of AI, in my opinion. Huh. Of course it's you. That's why that's why you asked that leading question. Can the framework await the promises? Yeah. That's. I see what you did. There is a model there. It's just not one that like we can do a lot more if, and you could argue that we shouldn't be doing this. The framework shouldn't be taking that on, but if we can do a lot more if we absorb that. Yeah. I mean, think about. Okay, can I put it this way? Svelte 3 was called the disappearing framework because it compiled all your JavaScript framework code into vanilla JS components. That was the argument. I mean, it's not 100% accurate, but that was basically the argument. And it did so by basically taking what you wrote and then generating a bunch of code that was very specific to the update paths. And in so was fairly efficient, and it kept the framework small because the framework didn't need to actually worry about very many things. It didn't need very many helper functions. But the problem with this is this. To do MVC size comparison. Obviously, another article I wrote, but I can't emphasize this enough. What happened to our app when we added 80 to-do MVCs in it? And now 80 to-do MVCs might seem a lot, but it's also not a lot when you consider to-do MVC is basically like one medium-sized to larger-sized component. Like maybe it's like 4 or 5 normal-sized components. So we're talking about maybe 300 components. Now, obviously code splitting and other things, but you don't have to get this far to see the scaling issue. React, Svelte is when there's one to do MVC is 3 kilobytes, and you're like, sweet, right? Where React's 37 back then. And now it's like more than that, but it doesn't matter. By the time we get up to 80, React's 134 and Svelte's 150. Because all that code it generated, because it didn't reuse helper functions, it wasn't as tight, it actually got larger. And actually when you added hydration to the picture, it got even larger because of the special code paths it used to have for hydration. This is like one of the biggest motivations, I feel, not the only one, but one of the big motivations why they moved to signals and something very similar to Solid in Svelte 5. Because Svelte 5 is like this. It does not do that. Right? And the problem was that to actually write the code, there was value in having a shared library. Like, and another way to look is the value of having like there's enough common patterns that abstracting it actually made a lot of sense. Now, don't get me wrong, AI could also design the abstraction as well, but in general, a general solution didn't kind of fit in, and more so when you consider all the edge cases you have to handle when, say, talking about something like async, the race conditions, like, and you can picture this yourself by, we did this on a previous stream, by taking something like React 16 style and trying to implement the proper async implementation. It's not nice. I actually showed this off on stream where we actually came up with something last stream, I think, where we actually came up with something fairly reasonable. Actually, it was the stream before, but it still was broken. And then we actually went through an example, but the simplest example ever, and actually fixed it on stream. And it was way more complicated than actually encoding that behavior in. So my premise here, and I was going to talk about this a little bit when I talked about the AI generated article, is that these, while higher level abstractions, opinions might get boiled away by AI being able to just junk this stuff together, so to speak, like meta frameworks, everyone's gonna have their own meta framework kind of deal. What all this is doing is putting pressure to push the core fundamentals into the language, into the core framework more. In a sense, React or Solid or Svelte or Vue or whatever is more like a programming language than it is like a library at this point, because of the way it abstracts over the JavaScript and DOM and HTML stuff. We can talk about transparency, we can talk about differences of compiler, all this stuff, but generally speaking, it's better to think of it that way. So while, Beat Plus might release a new meta framework that's basically lets you do Svelte or Solid React or whatever, generally speaking, we're not talking about replacing React in that equation. Do you know what I mean? So from that perspective, there might be a reality of this, but until the AIs can hold what I have in my head, that I actually can't even keep in my head, honestly, because it keeps on flowing out when I work on specific problems. Unless AI can keep more than I can keep in my head when solving every single problem it approaches, we're not going here anytime soon. Yeah, that makes sense to me. So wasn't this an AI question? It's talking about tokens. Sorry, did I misunderstand this? I thought so. Yeah, in any case, a little bit of a tangent. Where were we? I don't even know where we were anymore, honestly. That got so deep down. Yeah, I was gonna start talking about effects, I think is where we got to. And I was saying that there are some different approaches here. The Dependency effects must be known at computation time. Okay, this is a true story. And actually, let me pull something up here, because Rich Harris actually responded to my article, because he said he disagreed, and I think he has a right to disagree here. Let me see if I can actually find it. Okay, because in Twitter posts I disagree. He didn't argue with me about the flush semantics, funnily enough, which is actually, I think, the trickier one. But if async is only discovered during side effects, it's already too late, which is true. The solution is to update async stuff first, then run side effects once resolved. Repeat until settled. So you have something like this, and slug changes, right? Okay. Then the post starts updating immediately. In other words, while it looks like a derived, it's actually a special kind of effect that gets a jump on the queue along with the control flow. The compiler creates these effects where they see a way. So he's basically describing what Svelte 5 does, which is how they get this thing. So within effects, the world is consistent. You can force inconsistency outside effects or write slug, blah, 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 but easily avoided with the system could warn without necessary. Okay. So basically what he's pointing at here is, because they have the compiler, they can scan for these await keywords and then do like a special transform kind of hoisting to ensure that all of that is resolved before running any side effects, which contradicts something that I actually said in the article, and he's right. He's definitely right. There's impact of this change, but it's not impossible. The actual invariant is this one. This is true. This is the physics. This is what you can't actually argue with. But the solution of using a compiler is viable in some cases where I said it might not be. So why is this important? I feel like this one's a lot easier to understand, but it's, if you pretend these console logs are effects, like each independent effects, like essentially if you have the ability to pause or halt or execution on any one of these, you have no clue what's going to log here. Like pretend A returns the letter A, B returns the letter B, and C returns the letter C initially. What gets console logged? I've used this example on stream, but I really want to nail this down for people here. Can someone tell me if fetch A returns lowercase a, fetch B returns lowercase b, and fetch C returns lowercase c in some kind of like async blocking kind of system, what gets console logged by this effect? Obviously, it depends on the system, but I'm like very much open to guesses here. Right. I mean, you obviously have to answer that with this thing. Like, do we assume that they're null initially, or do we assume that they throw, or do we assume, like I use signal semantics here. Now, if they were awaited, granted, then the answer is fairly straightforward. It would log A, then B, then C. Right? Yeah, I'm saying that these three are promises. I'm just saying if you have some sort of system that absorbs these promises, right? So, yeah, so for Robbie saying, like, if you throw, it's A, B, A, B, C. Maybe. It could also be A, B, C. And I think it can also be... There's a world where it's ABC, I think. Is there a world where it's ABC? Yes, there is a world where it can be also ABC. If C results first, how would it be? Yeah, and it can also be A, B, A, B, C. Yeah, that's the last one. I think we got them all. Yeah. Perfect. I think we captured them all. So we got A, B, C, A, B, C, A, B, C, and A, B, A, B, B, C. Right. And you might be like, who cares? They're console logs. But picture if this was actual side effects, the work you have to do. I know that effect will run only when all the problems are run, so that you showed a long time ago, right? Well, here's the thing. I'm just saying, in general, we don't actually know. It could be all of those. Yes, that's where I'm getting to here. It's even more fun if these can get updated after the fact. So that's initial run. What if B triggers an update later, and then while it's updating, A triggers an update? Like, honestly, you don't know. And that's only one effect. What if these were all separate effects, right? And you need all the effects to run at the same time to be synchronous, but each A, B, and C are each logged in a separate effect. So, A is there, so you go and log it, and then you hit B, and then oh crap, it's async, I can't log it. You've now broken in the same sort of way because you weren't able to resolve all the effects Like what if these are based on the same change, like count, double count? What if these were all double count, triple count, quadruple count, right? You've now broken the chain somewhere. So now you show the count and you show double, but you don't have triple or quadruple yet. So you show the old value or you show null, or like the UI affordances can always be figured out because you can always design around them. But I'm talking about like the consistency in your data graph. What is this supposed to do? See, it doesn't really matter until you get to the side effects where people can see though that you actually have a problem here. Because if A, B, A, B, C, A, B, C, if nobody sees this progression, there's an efficiency question, obviously, but like for performance. But generally speaking, it doesn't matter because if no one's tree falls in the woods, no one there to hear. Like there's no side effect. But as soon as you add side effects to the equation, it's not just enough to know all the dependencies up front in a particular effect, because like if I rewrote this example to something like this, like if I took this and I was like, okay, simple, const a equals a, const b equals b, const c equals c, and then I just went like, if I just did this, and it's like, okay, no problem, guys. And you asked me what it logged. It's actually really easy now because we can just say it logs ABC. If there's any kind of pausing or interruption value here, no matter what the order is, this will log ABC every time. Right. If you make it a wait, I mean, there's one challenge with this, which you already know, is that reactive tracking is synchronous. So in order to do that, you would actually also have to wrap the wrapper with the context somehow, or like async context or something. So, and honestly, I'm not even sure how I feel about that. I think my perspective is changing a bit over time, but like traditionally, I don't even like the idea of tracking after a wait. I don't think it makes sense because now you're connecting to places in time that you shouldn't be. Like I actually think the sync constraint on tracking is actually a really, really good thing because you don't necessarily like if you track before and a wait and then track after a wait, you don't want to necessarily start the whole thing over, especially if you're doing expensive work. Now, obviously, you can say hoist the fetching outside just to wait the thing, but then why are you even awaiting in there anyways? You're forcing a microtask on something that doesn't need to be a microtask. Like the whole shape of the solution is awkward. Yeah. So because if this throws or this throws or this blocks, we basically move everything down is what I'm trying to say. But the problem with this is that's fine for one effect. Now I have two effects. This one depends on this, and this one depends on this. Ta-da. I have the same problem. It's not enough to hoist it to the beginning of the function. I need to run all of these before I run any of these. Yeah, but you understand the whole problem is throwing. I am saying throwing, but throwing is too late if you interleave. If you have the initial problem that I have in my article, throwing is too late here. If you throw at B, you've already ran A. Throwing doesn't solve this. Awaiting does because it has true continuations, but now you are in an async world. Do you wait every value? Well, no, you wait promises, which means like there's consequences of being colored, and we'll talk about those a bit more in a minute. But what I'm getting at is this is why there is an important distinction here. My premise that you have to like basically do what React does with dependency arrays is because it's colorless. If you are colored, you have the ability to know what you're dealing with ahead of time, like Rich was talking about, like with his compiler. But there is still like an awkwardness. Like if there wasn't a compiler, let's say you were completely runtime, you wanted this solution to work without any fancy compilers, just be pure JS signals library. Sound like a library you know, right? I'm big on plain JS from like the runtime perspective on that side. We don't compile your syntax. We compile your templates. That's it. And what I'm getting at here is in that kind of world, it's a lot harder because yes, you can await in here. You can await in here. Let's like don't get me wrong. Now we're awaiting, right? In fact, we can even await our original example, right? Let's just go back. Let's go back. Let's await our original example. So now await, because we know that these aren't actually async signals, they're signals of promises. Okay. So now we're awaiting them, right? This will log ABC technically, but it'll also always log it as a microtask. It will never log ABC, right? It'll never log even after the fact, even when updates happen or whatever, it never logs ABC. It always logs A, B, C. Right. And and there's other consequences here potentially. I don't know if you're expecting like it to trigger like lazy. Yeah. Like the problem is, and this isn't avoidable by you, the await keyword does this. Now, if you made your own venables, like made a special signal like this, and then had your own read semantics, but even then, you need the this is actually tricky. I don't think you can do this without a compiler because await means async function actually means 100% microtask. And if you wrap it, you lose that still. There's no type of wrapping that avoids that microtask. What you can do, if you look at, like, go look at Svelte compiled code, these awaits disappear. They actually compile them out. I mean, it's clever, but there's other impacts of this. Do we need Promise.all? You could, but Promise.all again only helps us in this scope. You know what I mean? Like, Promise.all will at least push it onto, I think, one microtask instead of multiple. Yeah, I mean, we need that as well. We also need read A, but I'm saying read A enough isn't read isn't enough here to avoid the microtask. I mean, monkey patch all side effects and then entire DOM and defer them automatically. I mean, what I'm getting at here is I'm hoping you're starting to see that even though we're working in a computer world, that there are real constraints to the system. There is physics. Now, in my article, I said that the solution was this, right? It looks like a dependency array because it is basically a dependency array. Because if it doesn't have to be a dependency array, but I'll show you some key differences here. But if you do this now, you separate the tracking from this. You can do all of this before you do all of this, and more so if you do this, and you know this one has B and C. To go back to my other example, and this one has A, at which point it doesn't even need to be wrapped. In fact, we can just do A, and then this one can be A. Sorry, get rid of A. If we do this, we can run this and this before we run this or this, and our system is consistent. And this did not take a compiler. It did not take any, it does not force micro tasks on you ever, except for when it has to wait. It doesn't force like after the fact micro tasks. Like if these values are available to you, then that's exactly what you get. The new syntax is so ugly, it's probably a very good feature. Yeah, I mean, because you really don't synchronize state with effects. Don't use effects that you don't need to use effects on. Like I actually, even though this is uglier, I almost view this as a feature. Yes. Yes. Because generators don't have to go async. So as long as your primitive exposes the ability to sync read, then like you patch something that isn't a promise. And you could actually also handle your yield in one way. So generators are actually one of the cleanest solutions here, because what you can do with generators, which is really, 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 really nice, is, and yeah, I mean, Milo actually tried to build a whole version of, before there's reactively and there's R3, right? Solid's based on Solid 2.0 started on reactively, which is R1 essentially, and then is built, Solid 2.0 now is built on R3. And you guys are probably like, what happened to R2? R2 was built completely on generators. So what's cool about generators is you can do this. There's two things really cool about generators. Console.log yield a. We'll do it like this. What's really cool about generators is that we don't care. First of all, you notice there's no function call here. It's because the yield can be just the read. We don't actually need to call a function here, and even if it's async, it can happen after. And so instead of having explicit read call, we can actually resume our context simply by doing the yield here. So like we don't actually, even though this is like could be async, not async, we don't know. We have the ability to continue without having a special track function or read function. Secondly, we don't care if it's async. If it's a promise, if it's async, whatever, we can handle it. That detail is buried. So technically, this is like basically perfect, except for everything that you ever do from now on is going to be wrapped in a generator function. And what else is not great about this? Performance of generators is generally like when you try and make it, like Milo basically had to just stop this experiment because of performance. And now, so this might be the question where someone asked earlier, is performance a gap on the reactive systems? In this case, yes. We also played with this in Marco. Like on the server rendering, this actually makes a ton more sense, because I was saying there's actually a crank.js, which is based on generators, which also is an interesting experiment. I don't think components should be generators. I think that was the issue with Crank. Like I think if you had a run once model with reactivity as generators, that would be very interesting. But Crank was almost like a React model in a sense, like where like the components were generators, because they were trying to like do async flow. I think with a small refinement, generator is a very interesting place, because yield hides all the async semantics in a way that is consistent, allows you to do tracking, and completely works. So yes, but there's a couple gaps. People don't get generator functions generally. Like it's like really hard. People get like almost upset when they see them. And secondly, performance is terrible. Really? It's going to be the same problem as await read 8. Can't I No, I mean, does it force? It doesn't force me into a micro task too. I'm saying like, what if my primitive still absorbs the fact that it's a promise? Like if A is a promise and it's colorful, yes, but I think if this is colorless, this doesn't have the same problem. I mean, we tested this less than like maybe 6 months ago. I also think that this is a little bit too exotic, as people are saying. Like it's pretty really exotic. Like even we're testing the idea by bringing generators into our actions. I think. Oh, right, right. Well, no, I won't. No, my point was that it can be synchronous. This can be synchronous. Yeah, but I don't think it matters. I don't think it. Yeah, yeah, I get what you're saying. Like you're basically opting into a model where you're okay if some side effects show up later. Like this is not good for rendering. Like the DOM. Yeah, you're right. The late discovery is still a problem. I was thinking that. Yeah, you know what? Yeah, late. Yeah, yeah. This isn't even 100% solution. This is like good in the sense that like the effect itself executing is fine, but it doesn't actually again doesn't help us really with like this either. Like this is still a problem because we don't discover this until I mean yeah. Yeah, exactly. Thanks, Robbie. And you guys are dead on. I got way too excited about generators. So yes, supporting my this is physics. That's not what impression I got. Maybe there's some new stuff that I haven't seen yet, and I'm excited too. My impression is more that what I'm talking about is more like the Rust of JavaScript frameworks. You'll see when we get into Sol 2.0, for better or for worse, because the way that you constrain this stuff is through lots of errors and control mechanisms. And Remix is more like the jQuery. Like it's like lets you write as much garbage as you can, but then it can absorb it. So, okay. Well, I mean, so yeah, yes. So our conclusion is actually generators don't solve this either. So you're forced to basically do some kind of in scope compiler analysis, or just freaking split the effects already. Now, is this? I think this is better than React's dependency arrays for multiple reasons. First of all, first simple thing is we have prior art here. Vue watchers have done this for years, even if it was for slightly different reasons. It proves that people can work with this. It's not. I don't remember people complaining about Vue watchers because Vue only got the combined effect like in like some point in Vue 3. I think you had to do watchers all through Vue 2. Nobody cared. Like it wasn't like React. And I think there's a couple reasons for this. First of all, this stuff is dynamic still. It's not a fixed thing. You can conditionally subscribe. You can change the dependency arrays. You can like it doesn't have to be an array. It can be an object. It could be a single value. It could be whatever the hell you want. It can be deep. It can be nested. It could be whatever does shape, form, whatever you need to track. It can be done. Don't get me wrong. There's pain point here around deeply conditional logic stuff that probably should be split into multiple effects, for example, or like requires stuff. Like, don't get me wrong. There's limits here, but purely point one compared to something like React is it is still very much dynamic. It can still discover dependencies when you call a function that isn't in scope, right? Second difference, values are passed through. You don't read C in here, like as a function, you read it from here, which means that, oh, what if I miss a dependency? You don't miss a dependency, because if you try and read C in here, we'll tell you that you're reading in an untracked scope. I think I finally got that bug fixed, that it wasn't working. You know, no, I probably should update my template here. Actually, let's go stack blitz for a second and go, what have we got? Beta template, solid 2.0 beta template. We did a release today, right? That's what I was doing a few minutes ago. Let's update the template to beta 4. Oh no, sorry, this one's beta 2 still, I think. It might be beta 3. Let's update this one to beta 4 and beta 4. Save. Let's just refresh the whole thing. Should an effect also throw when you read a signal in effect inside of an effect, like inside the back half? Maybe throw. I've been playing with warnings, but let's fork this and play a bit, because hopefully those things that I was trying to show in the previous stream actually work now. Okay. So let's go here. So our first thing is, let's gut all of this stuff for a second and just give myself a hello. Am I alive? Yeah, hello, I'm alive. Beautiful. Okay. Second thing we want to do. We want to, what is it? Import, create signal, and probably create effect from solid.js. Beautiful. Okay. So let's go const count. We're just making a counter. Set count equals create signal 0. Beautiful. I mean, we can count in the UI just for fun. Whatever, let's just make it a button. Yeah, I'm glad HMR is working properly now. Click, do the simple thing, set count C +1. Lovely. Okay, cool. Counter working. Okay, so let's create our effect. Create effect. And let's make it depend on C, but then do something funny like console.log C. Sorry, it's count. Depend on count. And console.log count. Sorry, I don't know why I refreshed there. I didn't need to. Is this gonna work properly? Reactive value read directly in an effect callback will not update. Move it to the tracking scope, JSX, a memo, or effects compute function. There we go. Thank God. So, and it's going to keep on bugging you about this. So right off the bat, if you try to read a reactive value on the back half of an effect like this, it's going to tell you you are doing bad things. Okay. Thank you. Just like if you tried to read count out here at the top of your component, it should also tell you that you're doing bad things. Although I'm not seeing it. Why is that one still not working? Oh, it's annoying. I spent so much trying to fix this. It actually gives you the component name and everything. Oh man, that's so annoying. At least the back half of the effect one's working. I fixed, you know what it is? Solid refresh. I had the fix solid refresh. That's why. Let's remove our node modules, remove our package lock, the pnpm lock YAML, and let's try this again. Yeah, deps before side effects are much better than deps after React. Yeah, well, because you pass them through, right? All right, so hopefully this was just a module update issue. Yes. I don't. A reactive value read directly anonymous will not update. Move it into a tracking scope. Ah, it's anonymous because of this style. Oh, that's unfortunate. It can't tell the name. Like if this is called function app, it would know. Like if this was instead function app, it happens. Reactive, oh, but it's your compiled name. That's interesting. Reactive values read directly in app2 will not update. Move it to tracking scope. DSXMMO thing. That's okay. It's not perfect, but you get the idea. React value read directly in effect callback will not update. So what you understand what I'm getting at here. We were talking about the rust of JavaScript frameworks, right? The funny thing is, you might view this as like, does that mean Solid has a bunch of hook rules? There's now a second rule. There used to be a rule about losing reactivity, right? You don't want to read in a top level scope, right? Now there is a second rule, which is that you don't want to write in a tracking scope. So, but they essentially are the same rules that filter out of this. But what's key about this, which as I said makes me really really happy, is silly stuff now like if someone does something like counter and does things like what do we want them to do here? Destructure. And they're like, damn, why does this count never update? You know what I mean? Well, it starts by actually, someone takes some React code, right? Fine. I mean, this is what count is a number, whatever. Okay. Okay. Sorry. Did I do that? I did something that broke something. That's funny. I'll figure it out in a minute. Let's make this. Make it this. Go counter. Count equals count. What did I break? Okay. HMR is not perfect. Hopefully what we will see here is, why am I not seeing the, it's funny. Reactive value read directly in the callback will not update. Where is, destructuring should have found that one. Let me get rid of the effect callback one for a second. There's so many other warnings in Stack Blitz. Yeah, reactive value read directly in counter 2 will not update. Move it inside a tracking scope. I guess it's solid refresh, which is renaming everything. Because it has to make a wrapper. That's funny. But you get my point. Destructuring, it basically tells you that you read it in counter and it's not going to update. I don't even know. I don't make opinions about stuff like this. I just wanted to kind of like sanity check here that this stuff works. So yeah, essentially annoying all the weird Stack blitz issues, you can actually see that this doesn't update, and it tells you exactly why it won't update. Move it, reactive value read directly in counter 2 will not update. Move it into a tracking scope, JSX, a memo, or an effect, compute again. So you might not know that you're destructuring props, to be fair, but at least there's a hint. The funniest thing is, since I added all these warnings, AI has gotten like, I mean, AI was already okay at this stuff, but like AI immediately like sees stuff and it's like, oh, there's a warning, I shouldn't do this. Okay, let me rear into this. Like, especially for like writing tests, it's like almost like an immediate signal for AI that it's doing the wrong thing. It's just like, okay. Yeah, I didn't see this because in tests I don't see this. The name mangling is happening. Like, this is only dev warning, so it's fine. The name mangling is happening because solid refresh. We could probably reverse the name mangling so that the original component name is what gets put here, and that the name, like the mangling, happens to the other one. Do you know what I mean? Like, there's probably a way that I can make this better in solid refresh. No, what's happening here is that I'm I'm destructuring here, which is doing a reactive read. That's the problem. People hit this and they like, we have warnings in our linters to prevent this, but now there's a runtime warning that tells you, hey, reactive value read directly in the counter component will not update. Move it into tracking scope like JSX. So instead of doing it this way, if I change it to props.count, what'll happen is this warning won't exist anymore, hopefully. Looks like I have preserve log on. Let me see. Or stack width just preserves the log. Okay, whatever. But if I refresh it, you'll see that there's no warning anymore, and that this actually updates properly. Of course, I still need these types here. Count is a number. Log the function itself so it makes it clickable to find the source. Yeah, I need to do that more often. I'll update that in the next version. Thanks. I'm not destructuring a number. I'm destructuring props. Right? Props is an object that has count on it. So what I was doing was I was destructuring props. This is perfectly valid. That's why you see a 0 here. If we initialized at 5, you're going to see 5 here. The problem is it just will never update. People do this in React all the time, but it doesn't work in Solid, and now we warn about it. But just a side note, what I actually wanted to focus on here was that the effects, the shape of effects here, like with create effect, is actually kind of nice from the perspective that people are always like, I'm worried that I'm going to miss a dependency or something. It's like, you're not going to miss a dependency because you wouldn't have it to use. Like, that's not a concern here. You can't log count unless it's a dependence. Like, this kind of flows out of it, right? Because if you try and read it directly, then it's going to cause you an issue. So this basically gives you the right guardrails, because you're not going to miss dependencies. You're going to maybe oversubscribe. Yeah, getting into this is a godsend. I mean, to be fair, a lot of these can be found by ESLints, but there's ones that can't be. Like, the back half of effects is probably not easy to discovered by ESLint. I guess it could. It could look literally for the signature, but it might not find it in my custom effect or something. You know, like these can be anything. This can be a custom hook. No, and I'm glad you asked, because that we're in the next area. Can a compiler solve this? And I'm wrong about this in a certain sense, but I'm not wrong on the other sense here, because this is the first thing that people go to when they're talking about this. And the thing is, compiler can solve the general problem, as Rich pointed out, to a certain degree if you have colored async, but a compiler can't undo the effects dependencies from a generic like colorless standpoint. So could a compiler extract dependency from a single effect function? In a shallow sense, yes. React's compiler does exactly that. So does Felt3. But the compiler-based extraction only sees what's in scope. It can't see the whole graph. If your sources are functions that call signals rather than signals themselves, the compiler has no way to know whether those functions are pure or whether they hide side effects. That's exactly why Svelte5 moved to ruins. Compiler time dependency capture hit a hard limit. It couldn't track sources that weren't syntactically visible. What I mean is, if you've ever done something like this in Svelte, you'll know what I'm talking about. This in Svelte 4, this is like a reactive value. So if you put doubled equals count times 2, it will update. But if you call a function that does the count times 2 out here, Svelte couldn't see it. Svelte doesn't, like React would move like, compiler would like get double count out. Yeah, let me make this a little bit, let me use React language and or solid language and make this a little bit more visible for everyone so you can understand. So let's make this solid now. So we want count, set count, okay? Okay. So equals create signal. Okay, so we're using solid syntax. And then this here is a memo, but I'm going to use an effect here. I'm actually going to use a split effect for or like a React style effect. How do I want to do this? It's fine. I will use split effect here. Like I'll use the new solid APIs for the sake of trying to show this. There's only one dependency, so but I'm going to still destructure it for the sake of doing this. Okay, cool. So console.log effect, okay, or count. Now, I guess what I should do is what I should do is actually write what you would think you would write instead. So let's go here. Let's pretend our effects like this. So this is in, and this is compiler out, okay? So the difference with Svelte or solid, and it's kind of important here, Svelte doesn't have this, right? And React doesn't have this. So when they look and extract the dependencies here, their first thing would be you'd have to have a special processing that unwraps signals, right? Because anything that you saw here that was closed over, you would have to know like how to handle it, right? But the question is, what should it handle? Because let's change this to get double count for a second. So this is a function. In React, what you would do, generally speaking, is you'd extract the function, right? And then you'd go, okay, so get double count, and then you could call get double count here. This doesn't help us because you're still calling the function in the wrong spot, right? Like, the reason this works in React is because um, the component reruns. So every time the component reruns, this reference will change. So like when you update count, you get a new get double count function, which means that this will invalidate and then you will call your function. But that's not good for us for on a reactive side, because we actually want to track the reactive reads, and this function never gets recreated again. So what's your options? Well, you could not call the function here, essentially, and like do something kind of smart where you're like, okay, I see the function, I should call it here. But the problem with this is, how do you determine it? Like in something like Svelte, you can see that the reactive values are local values, I think. But what if it's coming from somewhere else? Like what if this is actually a function? You don't know if this function is get double count, which is what we want to do, or if this function is do crazy side effect. What's different between these two functions that tells us which one should go here and which one should go here? If it's just a symbol like React does, it doesn't matter because you're going to do all the work here anyways. But if we have these two functions and we treat them the same because they're function calls, also not good. What if you do create effect? I think I already showed this, that we give you a warning. You might have missed that part of the stream. If you do this, maybe it should throw, be a little stronger. But reactive value read in the effect callback will not update. Move it to the tracking scope, either JSX, a memo, or an effects compute function, which is the first function. So we actually tell you you're doing something wrong if you do this. So anyway, my key point here is, unless everything is kind of treated top level, like we don't, like the compiler, like this is the huge difference. React reruns, so when it looks at the dependency arrays, they're not deep. It doesn't really care. It just gets a symbol and goes, okay, if it's closed over, like basically there's something smart it can do here. It knows it can't read local state if it's not in the same scope. If the function's global, so it like doesn't change. Like the only way count gets into double count is if it's in this below this component scope, which means that when you rerun the component, you're going to get a new function, right? This is why like what use callback does, but it's kind of like funny in the sense that like you can invalidate, like if in React, if you want to memoize you memoize functions, like you might invalidate this function whenever count changes, which is like makes sense, but is completely bonkers from a signals perspective, like a single run perspective. Like you would never memoize a function. Like why would you create a new function just because count changes? You just read count. So in a sense, a simple system like React, which reruns components, or like Svelte 3, which reruns components, could get away with this. But as soon as you have deep, discoverable reactivity, you can't differentiate between, you have two choices. You have to force this to only grab actual known signals, so you kill composition, or you just can't do it. Like you risk leaking side effects. Yeah, well, and the funny thing is, the way we think is really weird. Like, I had guys from the React core team like arguing with me about this stuff, and they're like, "Well, how would you do this crazy case?" And they showed like this thing with function memoization. And I'm like, I never thought of memoizing the function. I just read the signal. Like they came up with a pretty good convoluted case, and my solve was so simple. Um, and like because they were looking to try and solve it in a React way, and I'm just like, just the function's a stable reference. Like that's not what you should be invalidating on. You should be invalidating on the actual things that change, which actually made the code cleaner and smoother. I think it was I forget who I was debating it with. I think it might have even been Seb himself. My point is, from a pure like hoist the effect standpoint, React can do this, but we cannot, and the same reason why we cannot is what gives us that richness that we can do stuff like this, where we can deeply discover stuff. It doesn't have to be count. What if it's a proxy with properties and stuff? We're not looking for specific symbols that, so we don't have to look in a shallow scope. This is why runtime reactivity is so freaking powerful. I think I will stay with React. It gives me job security. So the React compiler, so no, what I'm saying is the React compiler can't, and they probably won't. And Svelte already is solid system. I'm saying old Svelte was different, but Svelte realized that they couldn't actually solve this with a compiler, so they introduced runes or runes. They couldn't 100% solve it. The Svelte community was like very upset that they suddenly had the right state this, and they couldn't just do let count, for example. But this little bit of extra syntax gave Svelte enough that it could basically solve this problem. But Svelte isn't doing this. Svelte is doing it solid 1.0 style, where it just you write you write count. This is what Svelte 5 did. Svelte 5 took you writing this and instead outputs this, more or less. I mean, it doesn't use our syntax for destructuring under the hood. It probably just puts it on a thing, but it goes through and goes, okay, where's all the references to count? Okay, count is here. Make that a get. Where is this? This is already fine. Nothing special here. Yeah, and now there's no out here yet. Like all Svelte's compiler is doing right now, for the most part, for the signal stuff, is literally looking for where your call site is, taking the special object there, and then finding that symbol and just turning them into gets or sets. Oh, confirm staying on React? That's funny. It's supposed to do the opposite. Oh no, sorry, confirm this. That it always the only way to stay sane. Okay. That was a joke. It's all good. So it's basically just a solid wrapper. Yeah, I mean, there are differences in stuff, and especially in the async solution. But like generally speaking, the move to Svelte 5 put us very much in line, and Vue Vapor for Vue as well. Like Vue already had signals, but the actual rendering mechanics are much closer. There's obviously differences and stuff. But like it. I would say that, I mean, and this surprised no one, I'd say that Svelte 5 is much closer to solid now. Obviously, than Svelte 3 was to solid. Svelte 3 was basically, yeah, how do I frame this right? Because Svelte 3 was like React, but it's actually like Svelte 5 is more similar to solid than Svelte 3 was to React, but that comes as a surprise to no one. What probably comes to bigger surprise was that Svelte 3 was closer to React than it was to solid. That's probably the bigger surprise to people, like significantly closer to React than it was to solid. Okay. But my point is, in a pure sense, compiler can't solve this from the dependency. But if you attack this the way that Rich has, compiler can solve this, because what Rich did is a little bit smarter. So instead, if you recognize here that double count equals, sorry, const doesn't make sense anymore, whatever, it doesn't matter. But if you realize that double count is like $ derived await count times 2. Some effect of double count. What you can do is, like, I'm not going to say this is 100% how Svelte does it, but they can, first of all, they're not blocking your whole component necessarily. What they're doing is they're probably kind of doing something like async derived. Like, they're probably eating your await. Remember to change it to a function, so you call the count. And then their async derived, I believe they has the ability to block effects. So before, yeah, this one becomes a getter. So this becomes a getter. So essentially, although it has to do more than that, because how do they know that this dependency is on this dependency? Okay, let's see what spell outputs. Why guess? Why guess? We don't need to guess. Wait, we have count already. Let double count equals $ derived await. I'm just gonna do it sync. I'm hoping this still works. There's no name here anymore. I just want to see if this picks up on it. Oh, okay, yeah. Oh, it's even smarter than this. It actually looks for the okay. What if I had another one? It's that triple count. What if I do something in the middle that's completely unrelated? I'm just really curious. Count 2. Let's make count 3. Whatever, it doesn't matter. Oh, interesting. It tries to keep top level semantics through the async. See how above is fine. Let's do below. So count. Let's make this 3 and let's make this 2. Okay. So everything above the first await is not part of it, but then it basically has a special runner to process these things and guards the asyncness of it, right? Interesting. Okay, just aside. the details aren't here too important, but the important thing to understand here is that these now are kind of tied together. This is like the consumption point is in the components essentially, which is frees you up so that the rest of this can act independently. You know what I mean? Like, but there is definitely like this is like using use in a sense at the component level, which I think is what Rich is saying here. Push-based reactivity for async, push-pull for everything else. Obviously, there are trade-offs everywhere, and unnecessary selection JavaScript, but async forces effect splitting and DX downgrade the turn isn't true. Yeah, and he's right about that. Well, he's right. He's right about forces effect splitting. DX downgrade is arguable. I could argue his approach is a DX downgrade. Actually, we're going to illustrate why it is, but maybe not quite yet. We'll get to that in a minute. But I think the general idea still holds, right? In a sense, a compiler can solve this if you look for the awaits and hoist the awaits. It can't solve this at a signals level. Is my point. So does this mean we're doomed to mimic React? No, not at all. This isn't copying React. It's acknowledging the same fundamental truth, right? Async forces commit isolation. Async forces effect splitting. Views had the split in its waters for years. These aren't reactisms, you know? Like, they're invariants of any system that wants to preserve consistency in the presence of async, right? So, like, in my opinion, this doesn't erase the advantages of signals so much, right? Like, we are still surgical, you know? We don't re-render. It's only the effects that require the separation, right? That's a difference thing. Like, React, because the render model, they need the depths everywhere. They have a compiler to kind of compile it away. So, but like it's important that I think we acknowledge this. Anyways, to kind of finish out this article, I think there's some important truths. I didn't really get into why async forces consistent snapshot, but that was what I was trying to talk about earlier when I was talking about like the A, then B, then C. Like you kind of have to, you want your effects to all flush at the same time to be consistent. So when you have all of these aspects where you know, it doesn't, I guess it's wrong to say async forces effect splitting isn't correct. Async forces knowing the dependencies ahead of effects running. But it does force commit isolation, effects ahead, and async and a consistent snapshot. These things are true, right? So I thank you, Rich, for help like clarifying a little bit that effect splitting isn't an inevitability of the problem space. It's an inevitability that comes with being colorless. I think the more interesting argument and where we can go from here is kind of showing that you can't avoid going colorless to a certain degree. So you might as well embrace it is essentially where my next argument is going. But the whole thing is I don't think this suddenly makes us react, if that's what people are scared of. I did get a lot of feedback about this, but we should recognize, like I've always said, React gets a lot of things right for really good reasons. So like we should never be too quick to judge React's design decisions. I would say you can judge their implementation stuff to cows come home, but almost everything they do from like an API service side, from like a conceptual side, is pretty infallible from like a theoretical standpoint. So I mean, take it as it is. I thought this was a pretty pro React article. Because I'm basically admitting that signals libraries shouldn't hide or pretend or lie anymore. You know, this is a big step. I think this is important. I don't think this article really hit. I think it's well written. I think it's to the point. I think it shows great examples. But I'm not. I don't think people understand yet just how important this is and the conclusions from this are. But I mean, that's like most of my stuff, right? React's stale closures is arguably a feature in async, as it gives you perfect consistent snapshot. Yes, and that is, sorry, where was it here? That's what this did. Sorry, not count, because we err on that, or we warn on that. This gives us our consistent snapshot back again. Because you don't read the count here, this essentially is what returns, gives us that same guarantee. I like the way you're phrasing that here, because that is the key here. This count is in the past. I had this problem when I originally set up. If we actually go back full circle to the original article that I did on consistency here, looking at this 3 years later, when I first started thinking about it, I was really struggling with this batch behavior thing, because like I really wanted to be consistent. At this point, when you're outside of batches, solid worked like 1, 2, 2, 2, like the way that I showed. But when you were inside batches, it worked like React. So as soon as someone wrapped something in a batch, suddenly state updates weren't visible, and it meant that our code worked in 2 different modes. So if you wrote a function that did some stuff and then someone read it under batch, it'd be completely broken. And that was the biggest bug. I just had to choose a direction, essentially. Like, it didn't matter that much, I guess, in hindsight, which direction I chose. I think there's importance for correctness and stuff, obviously. But in a sync world, given the capabilities of signals, it actually didn't matter. I could go the React way and be consistent, or I could go the Vue way and be consistent enough. I just had to choose a direction, because having 2 different modes in solid was a death sentence for doing stuff in composability. The fact that batch completely changed how your code worked really messed with people. And in solid 1.0, we run all the effects in a batch function. That was intentional, because you don't want, like, in the middle of the effects run to like start triggering other stuff. You want to let the effects run all the way through and then do your thing. If you do them in the middle, like, the next effect will see different state from the previous effect if people are setting signals. And a bunch of people tried to argue that was okay, and they won, because that's where solid 1.0 ended up. They're like, what's the worst case happen? We just queue another effect on the back and we just eventually get there. But it meant that effects could kind of like run multiple times within a single cycle, depending on the order that signals set. And I never liked that, but I kind of accepted it here. But because in the original batch behavior, if you called set count in an effect, you couldn't see it on the next line. You couldn't see it in the next effect. You had to wait, like React does, until all the effects ran. So if you're in your event handlers, stuff happened immediately. But when you're in effects callbacks, they would be stay in the past. And I love that, because you had a consistent snapshot. Effects run consistently. They run to finish. They're always like run once. Everything was good. People in our community argued so strongly about it, because they were used to things like MobX, and they're like, look, it will be good enough. Reactivity will settle. And I'm like, yeah, but it's like you get in weird ordering states and all this stuff. And the only reason I eventually agreed to make this change in solid 1.5 was because of the 2 mode things being bad. I had to choose a side. And if I wasn't going to choose React side because everyone hated it, I'm going to choose Vue's side, right? Which is what I did. I always knew that that was not a great decision, that React was consistent and solid was consistent. Going to Vue's approach was a compromise. But it was a reasonable compromise. One that in a sync world we can live in. But in an async world, given that we can't live in it, yeah, like, look what I wrote here. So honestly, this all sucks. Enough that I feel the need to be aware of batching behavior. And with this awareness, I'm compelled to offer a consistent default that feels the sanest thing to do. For many of you, this is probably unsurprising. I'm the author of Solid.js, so why wouldn't I say that. Solid's eager updates work well with its rendering model and are completely implemented by opt-in batching. But the real revelation to me was just how much my opinion changed in the last couple of years. When I first saw this problem designing Marco 6, I was all in on Vue's batched reactivity. Being compiled syntax, having explicit opt-in felt out of place, and mutation not updating is awkward. However, I definitely would have put Svelte's approach as my least favorite. And right? But now I'm not nearly as certain. Working in Solid, which embraces explicit syntax, I have all the tools at my disposal. If batching is opt-in, and if I'm going to give up consistency for intuitive behavior and support mutation, I want predictability at least. And that Svelte's too simple model makes a lot of sense. So I actually couldn't, like, even then I was actually trying to argue for Svelte's model, just to, as I said, to avoid React's model. So coming from natural batching, I don't know if there's a lesson here. I can't fault anyone for coming to different conclusions. These tricky problems are why I love this work so much. Skeptics might point out Solid has all the update models in it, and they'd be kind of right. I don't know. Can't beat them, join them. Yeah. Yeah, when I look at this whole old article from 2022 in hindsight, I already knew what the answer was. I just didn't want to admit it to myself. I think we all kind of know what the answer is. Okay, so let's continue here. No DX standard. Let's talk about the colored versus colorless, because I think this is important. Because let's continue this discussion a little bit. So there's some potential in Solid we could get rid of split effects again, and the whole community has migrated to coexist with them. No, that's not happening. Not too late to change course. Yeah, I love how you guys make it sound like it's actually a bad thing when like split effects are so beneficial when you consider all the aspects. Yeah, and the create async API is not that, because create async for us is not where the read happens. It's not where the block happens. It's okay. Yeah. So let's start. Let's just scour all this for a second. Let's see if I can pull this out and get to somewhere where we want to be. Okay. So what's the shape of async? There's 3 points when you're dealing with async. The first point is where the let's pretend we're dealing with fetching, but like the first point in the measure is like creation, i.e. like do the fetch, right? The second point in async in a JavaScript framework or like framework is a consumption point. Framework absorbs the promise. The third point is read, where the value is actually used. Okay. These are 3 fundamental stages in when we're dealing with async in JavaScript frameworks. And I think it's important to look at it like this, because even if you're trying to like compare different solutions, you're going to find you're still working around in this space. So can I give some concrete examples of these APIs, perhaps, right? I already did with fetch, right? So what's this one like? Fetch user.id, right? Concrete example. Consumption. Actually, you know what? Let's do this a different way. Let me like go like, okay, how does this look like in React? Fetch user ID. Okay. Let's do props. Fetch user props.user ID. Okay. Sounds good. 2. Use. So this is promise, right? I'm going to call it p user, right? 2 is use p user. And 3 is Actually, let's get narrower than that. 3 is h1 user.name. Okay. No, the whole point of the stream is that this is basically science. Even when we disagree a bit on the implementation, all that, there is a certain science to this. You can like avoid the problem, but it's like it's there. Once you discover it, you can't unsee it. Okay, so this is an example of how this looks in React. React 19, actually, if we want to be really specific. Let's do the same for Svelte 5. First one is the same. Svelte doesn't use a props object, right? Or is it like $sign props now? I can't remember. Seems like everything is a $sign. Let's pretend that's right. But don't get me wrong, you can combine these. It's important that we see the separation. Okay. And then this is the same, okay? Why is Solid 2.0 different, you might be asking? Technically, you can do this, but in Solid 2.0, it's a little bit different. And I have to fix the Svelte version in a minute because this isn't reactive, so it's a little bit. I'll get to why this is important in a second. Solid 2.0, the design is that creation and consumption happen at the same place. Sorry, creation happens here, and consumption and read happen in the same place. Okay? Which is a little bit different here. See, React doesn't care because React re-renders the components. So there's actually a problem here with React because our first problem here is actually it's probably fine if the suspense is below. Yeah, let's pretend the suspense is below. Let's pretend this use is not in the same component. Okay, just makes my life a lot easier. React gets a new user ID, fetches a new user, passes the promise through to where the use is, which is where it actually uses it, and then somewhere below that actually uses the user. Svelte, if we wanted to react to the user ID updating, we actually have to change this equation a little bit. We actually have to, if you understand the problem, right? Because props ID has to be reactive. So we actually have to do this, if you think about it. I mean, we could defer this await as well. Like we can keep both of them, perhaps. But I think it's more, let me change the structuring here. Let me zoom out a little bit and kind of get to where I'm trying to get to. Because if you wanted to listen to this, it has to be part of a reactive expression. So essentially, what Svelte does is it puts 1 and 2 here, and then does 3 here. It's a very, like, these two things look the same, but they're different. Does that make sense? Do you guys following? Technically speaking, I can still separate 1 and 2 with Svelte if I separate them across like different boundaries. But like what I could do is it's hard because the fetch is based on the reactive prop, right? So it needs to be derived, but I don't need to await it yet. So I guess it's possible. I think it's possible in Svelte for me to change this. Sorry, this one's user. To change this to p user equals $ derived. Yeah, maybe this is better. Is this better? And then await p user. Like, yeah, I think this is probably the most accurate. Yeah, okay, sorry. Yeah, there we go. The reason I didn't put the function is because like under the hood, this is a function too. Like in Svelte, it doesn't really matter. Like, yeah, but if it's reactive, you have to listen to it in a reactive scope, I think. Like they might have some sugar syntax here that I don't have to wrap it in a derived. So like I like, but conceptually, what I'm trying to point out here is the await is the consumption point for them. You're kind of tempted to just put the await here, but if you put the await here, you fetch too high, or you block too high, the consumption point, right? So like you kind of want to, like I could be wrong about the exact syntax, but mechanically this is the consumption the same way it uses the consumption here. And in solid, the consumption is actually here. Like this is very, on certain way, this makes these things similar, like the mechanics, the way we hold is similar, but this makes things very different. And it's important for me to point this out because we were talking about dx, right? You could argue, as I said, that Svelte and Solid can have the same dx essentially, like when you squint at it, by essentially moving this to here, right? This is what I was doing earlier. Now, if we're like, sorry, let's move my thing a little bit this way. Now, if we're squinting, these two are the same, right? If I put them on top of each other, like create memo, fetch something, derived, fetch something, username. Like these are the same. And the same way I was saying that these are the same, right? But there's a huge consequence of this. DX wise, you want to do this, in my opinion. This is where you're tempted to do. You're just like, okay, just freaking await the thing, derive, get my signal. This is what you want to do. But splitting them is actually better for performance. Mechanically, you want to do this. You want to be able to, because in terms of where these points go is, this can be used in multiple places, right? P user. So let's talk some truths here. Actually, first let me edit this one. It's saying like phases of async. Is it phases? Steps? Stages? Phases of async in JS framework. Okay. All right. Cool. And then we have this thing. And then what I want to put on here is there's some other rules around this stuff here. I can implement it here. You want to do this as high as possible. Not as high as possible, but as high as needed. What I mean by that is if you use a user in like 20 components and down a whole tree, you don't want to duplicate this necessarily. So generally what you're going to do, I mean, there's caching solutions and stuff, but generally you're going to fetch as high. You might put in a global store. You might put in a store that's happening, like not Redux, but you know what I mean? Zustand, whatever. You're going to do this as high as needed up in the hierarchy. We might even be global. Maybe even global. I mean, I don't need to put that note. You get it what I'm getting at. Consumption. You want this as low as possible. You don't want to block unnecessarily. You don't want to cause waterfalls. You want to be able to like have the framework do as much stuff independently without getting blocked by async. And then here, well, that is, so, I mean, we can another way we can read this as low as possible is the read. Conceptually, when you're designing the system, you want to be able to fetch as high as needed, but consume where you read. That's the fundamental thing here, because if you consume too high, you can already see it, you block, right? You're like, if you're sitting there in your component, I don't need to pull up the Svelte example with the run. I don't know how blocking that is or how eager it is, but like they had to structure their whole async around it. If this is why I don't like async components in general. Like forget this for a second. If someone was like, I think my framework should have async components, async component, async function, component one, right? Lovely. Okay. Look at my awesome framework. Const user equals await fetch user. So simple to write like this. Const user posts equals await fetch user posts. Lovely. And actually, let's put some props in here. So let's go props.user ID. Props.user ID. It does not get easier than this. Like, look at the DX. And then I just like return, a couple components. This is lovely DX. I can go user. See this, just self-close it. Because we'll pass user here. And you might be like, well, why did you even do it here? Well, the reason is because user posts component actually needs both. So, we needed both the user. I could have put the posts fetched below, but as you'll see in a second, it actually doesn't make any difference. Lovely. Good DX. Yeah, which is good. That helps a bit, at least on a shallow level. It depends on how lazily the discovery works. But as I said, I don't think this actually changes the math all that much. It does exist earlier. Sorry, going back to that example, but let me get to the gist of the problem. I mean, actually, chat, if you're still awake, what is wrong with my picture? Why is this wonderful DX about the worst thing you could possibly do? Yeah, waterfalls. Yeah, like you're waiting for user to wait for user posts, and they don't need the waterfall because they actually depend on the same thing. You don't need user to get user posts, and I'm not even like I'm actually preventing my ability to even show anything, too. The waterfall is the obvious one, but async component makes it even worse because I can't even show a fallback unless it's like above it. Like like I can't proceed further than this. But waterfalls are great. It looks like RSCs. Yeah, about that. Well, the smart person will come in and say like, well, solve the waterfall. God, not hard, Ryan. Seriously, you couldn't come up with this. Not hard. See, our perfect DX is saved. Yeah, I'm completely joking. Promise.all doesn't solve your problem. I mean, it is a solution to the problem. Now they're not waterfalling, but you still have a bigger problem. It's still as slow as the slowest fetch. Now, it's quite possible that this doesn't matter. But look, user doesn't need user posts. So why the hell should user wait for user posts? Like Promise.all is not the solution. When people pull out Promise.all in their components, like when that's their solution, you know you're in the wrong model. Like you're doing the wrong thing. Promise.all is not the solution to this, nor is like on Promise settled or any like the interesting like split Promise race or what. No. Um, just use caching. Yeah, I mean that helps with the re-render problem with React, but that or just use caching from the perspective of like never fetch anything and have it all be cached. But what I'm trying to get at here is this is why you don't want to consume or block high. Now, it doesn't have to be a definitive block, to be fair. Like there's ways around this scenario, right? Like this is the definitive block. Let's not definitive block. Right. Actually, let's not definitive block. Now, or maybe I forget how this works. Where does the use go? Can I promise all with a use? It doesn't matter. Maybe I'll get rid of the promise all. Yeah, let's get rid of the promise all. Okay, so now I've invented my own keyword, so I don't definitively block. Right? This is better. Definitely better. I also have to have a caching system or some kind of concern with that built in now because like I actually have a problem here because if my component reruns and it fetches user again, I'm actually in trouble. So uh, using like this doesn't really work well in a rerun system. This is kind of what forced React's hand here. It's like why React is so you need to separate this. React like says like you basically should separate the creation from consumption. You like, basically have to, which is good because you actually do want them. These actually should live in two different places. The challenge is because of shared state, it's difficult to make this as low as possible. Once you start forking, if you want to derive it, I mean, don't get me wrong. Like, go ahead. We can make a component tree where, like, we have we pass something all the way through. Like, And like if we want to derive something, we could use promise chains, right? You can always like not this one, this one. You know, going back to our lovely example here, right? We have to pull this out now. So realistically, this is our user section component. So we could go like props dot user p, user promise. And then we can go somewhere up here. We'll make another thing like, let's call it app for now. And I'm going to assume the app knows about the ID here from its props. I mean, it could be like, I don't even know what to call this. It's not even an app. It's like user page has the routing information. And then we can do something like this and then make user promise. I mean, this isn't an actual real app. And props dot user posts promise, right? And then we can have user posts promise equals fetch user post. I should have just copied this before. And then we can, this gives us a good place to put our suspense boundary, by the way. Why not? And then now we can make our user section take user promise props. Or and then we just go user promise equals, and we can also do user. You know what the problem with this is? We should actually make this user. I'll continue with this direction for a second, but I don't like this for a reason. I'll get to it in a minute. We can make this user posts promise. The reason I don't like this is because, as it turns out, while this works, our user section actually also works in a place where the data is available and doesn't actually need to be a promise, right? Because like right now, our prop types are kind of like, what are they? User promise is what? Promise of user, let's say. And user posts promise is a promise of user posts array, probably. And then that will work. And actually, while we're at this, let's fill out this example a little better. Let's user posts. We don't actually. We can move this use down here, right? Because we don't actually need it up there. So let's move it here. Sorry, that's not what it is. And we can go props dot user posts promise, because we actually have to. Yeah, so our prop type here is we actually want user posts promise, which is a promise of user. Sorry, this is just, I know there's a lot of plumbing here. I just have to make sure that all my prop types coming all the way down are the right ones, because and it's also takes a user, which is not a promise, it's just type user, right? Okay, cool. I could make it, actually, you know what though? I could make it I mean, for now we'll just do this, and then that roughly looks right, right? Yeah. We should make it actually support both. So we could make it user or a promise of user in case, right? And then this could be user, and then our local user could. Can you use on a synchronous user? Probably. Probably. They probably support that. I don't know. Someone React will know user a little better. So then we can make it user posts or array or promise of user posts array. And then we should do that down here too. Because now we can go either way now. Which, if we go either way, we actually should probably bring this down here too and call the use here just in case. Right. And then, because we might use user post somewhere else. So I really want to make sure we're capturing the DX here, okay? Really want to make sure we're capturing the awesome DX here. Yeah, okay. So yeah, this is cool because this supports both, and we can read them both here. And then this is fine. We start it here, we pass them here. So these are actually sort of type user. Yeah, that's good. Okay. And then so this might be a type user posts. So it can be a promise or not a promise. And then, I mean, there is, I guess, to be fair, now that we do this, we can actually remove this, right? Because now our user could, we don't need the block there because we can defer the blocking here. Right? And now, yeah, exactly. And then our props will be of type user. I think I got it. Okay. This is not bad. I would argue that at some point, like we this is still simple. There's no conditional logic. There's no like there's no like if there's further conditional logic, then the use might, like, we can get the use pretty far down, right? If we want to. I mean, it's not into the template level here, although I think you can use in the template in React, but we'd have to worry about where our suspense boundaries are. Like, I think probably in this case, we'd probably want, because we have to either use a post here, we probably want to wrap this one in a suspense boundary too to make it a separate boundary. Right? Wrap that one in a suspense boundary too. Yeah, I like that. Yeah, we can make maybe promise is nice. Yeah, let's go through here. You know where I'm going with this, Robbie. No, maybe promise is T or promise T. I like that. Maybe promise, yeah. Nice. All right. Okay, cool. And as I said, the proper solutions felt 5 probably looks 90% the same as this. Oh, you're right. I'm missing the T. Okay. Yeah, I mean, to be fair, this level of prop drilling is not that bad. I made it seem really painful because I sit there and did all the promise. It's not just a prop drilling. I also have to actively consume the use in the places as well. And I mean, it would have been a fun exercise, I suppose, if we had started with the system being synchronous and then added the promise to it and then basically went through and rewrote all the components. Because the difference with the colorless system is I could make the change right here and not touch any of these other components and they'd all work. Right. It would be just as bad with synchronous. You're right. But if it was, but changing from sync to async is involves touching every single touch point, and then actually the use is actually and the awaits are actually additional overhead over synchronous too. Well, I mean, we like the reason that I'm trying to show this off here is this is mechanically what you want this separation here mechanically, but how tempted when you have a run one component are you going to be just to do this? Because picture, I did this in React syntax, but picture if you like you could picture if your component structure wasn't like this. All these maybe promises weren't there, right? 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 So I'm going to remove all the maybe promises for a minute. And you didn't have any of these uses either, okay? Okay. Let's look at this a little bit more practically, right? And you're just starting here and you have this conceptually, right? And someone came in and were like, okay, well, this is simple. We have an async primitive for this. So all you have to do is do this. User, and then you go, okay, I'm going to do derived. I'm going to use like a solid like syntax here, but I'm going to do derived await fetch user, or let's call it memo. Doesn't really matter. Memo await fetch user. Ta-da! Guess what? This is like a reactive library, so we don't need the like, you know, like this should have been a await or some cached out. It doesn't really matter, but so we know that we can read this underneath here. So technically, I didn't need to change. Sorry, user posts. I didn't need to change any of the components. I just wrapped it in an async derived at the source, and everything works. And you're like, sweet. Except there's a problem, actually. The suspense boundary doesn't go here. Actually, the suspense boundary goes out here now. So you're like, okay, whatever. I'm just gonna, I mean, this is not hard. Return suspense. I know this is a weird hybrid, weird component system, but I'm just like, this is not real, this is not svelte, this is not solid. This is just user page, and we're gonna pass in user ID, whatever, doesn't matter. So what did I manage to do here? I saw something that I had some async, and I was like, sweet. All I have to do is create a boundary around my async, and then just async derive it, and everything I have automatically just works. That's great. That's great DX. I'm missing a comma somewhere. I don't feel like trying to figure out where I'm missing that comma though. Because it's really easy. I can just take my whole app that did a bunch of stuff, right? I probably didn't even have this suspense component down here either yet. No. And I can basically just add some async fetching up high where I was doing my fetching, would do my fetching, and then wrap it in a boundary and call it a day. No, that's not my only point here. My actual point is the DX that you want is solids DX, but that's not what you get. This, if you give people the ability to do this, they will do this because this is what you would do in solid, right? The difference between this and solid is that this blocks here, not down at the leaves. The solution, it works, but it blocks at the wrong place. This is great developer experience. This is easy. Unlike React, you don't have to worry about the components rerunning per se, like in whatever system this looks like. You know, you just make it an async memo or async derived value, and you just wipe your hands clean of it. The rest of the system isn't aware of the asynchronicity. It all loads and it all works. This is the path of least resistance. It's also the path of least performance. People will gravitate towards doing exactly this. I mean, wouldn't you? You just saw that what we had to do. We had to go through, update all the props, add all the U's or weights all the way down through, go through every single component in this tree and do this migration. Or we could just freaking fetch it at the top so that we get rid of our waterfalls. Guess what? This maybe this is a route loader. You know, like this is, you know, we already do this. And then basically, like, look, there's no waterfalls here from a data fetching standpoint. But I mean, from a UI standpoint, there are. Like if you were streaming, you're not getting what you want out of it. This is you are naturally going to go this direction, right? Like, and this is what I'm getting at. React, the confusion was people wanted to put fetch user directly in use, right? You want to put await fetch user in derived. Yes. Now, the height isn't determined. Sorry, which feels, even though the complexity behind the scenes, the API service feels correct. Yes, we basically turned our app into a Promise.all. And you are, Rob, you made my point. Yes, this is exactly what I'm getting at. Like, we have the natural tendency in our imperative thinking to turn things into promise.all. So React doesn't let you do this very easily because you need a caching solution, components rerun. It's kind of like a saving grace that the system completely explodes if you try and do this. It's not convenient, but it's kind of like a saving grace. But when you have a reactive system that's actually reactive and can update the stuff and can be fine-grained, you just gravitate towards doing it this way. You know the right solution. You know the right solution is pass the promise through all the components, go through all the types and check if the differences are and push them to the leaves. I was arguing that people probably wouldn't move it into event handlers. Good luck moving them into component properling patterns or whatnot. And the funny thing is, okay, you said yourself, how often are you moving from sync to async? But even think of the process of new development, what people are going to do while they're developing new features. Maybe it was just a user page. And then maybe over time, you added user sections and user and split it out and started these things got bigger and started adding maybe nested fetching or just like they started naturally expanding out under their own weight as features come in and increase. Everyone can picture this. You start here. I mean, I don't even know how anyone can make I know there's no science to developer experience, but like this seems very obvious to me. So the whole question is, what if you could write this and have it behave like what we did before with all the uses? Actually behave even better. Pretend the uses are in every single reactive expression. Pretend the awaits are pushed down. Pretend that in between here, if you decide to make a full name, like think about what if somewhere in here you needed to do something like make a full name? You'd have to consume with the use. If you didn't want to consume with the use, you'd have to go like promise.then user.name to full name. Like you'd have to compose the promises if you didn't want to use hi, right? Like I don't know why you'd want to do that in this case, but what if you want both of these to get user full name and you like it was an expensive calculation, not something you want to repeat in multiple places? If you wanted to do it at this point in the tree where you're holding promises, you either have to block here now or you need to actually like make promise changes on derivation. Like, you know what I mean? Like, how do you deal with it? You're like, okay, well, user.then u.name to uppercase. My examples are dumb, but my point is that if you're not dealing with user, you don't get to just go like that. I mean, you can make more, you can make more async derives, right? But if those derives are blocking, like if the pure presence of a wait causes the behavior, like is the use, how do you do, like, then you shouldn't be awaiting. You should be, like, if the compiler is looking for a wait and you don't want to wait behavior, then you can't use a wait. Then you're probably going to use then. Do you know what I mean? Like, it was like what I was talking about earlier when I was trying to figure out how to write the example in the Excalibur, where it's like, I don't want to await here. I want to await here. I want to pass the promise through. But what if I actually have to derive something from the promise before the point that I want to await it, and I want to await those in two different locations? Well, then you basically promise chain without using await, right? Well, it works like Promise.all in a system where the consumption or the blocking or like the trigger of saying like, where is my suspense boundary or whatever happens where the await is or where the use is. I like the suspense has to be above that. You know what I mean? Like that's why it's like Promise.all again. In this case, I probably would have started with either drilling down user ID or adding it to context. Yeah, I mean, adding to context helps in a sense, but like what I'm getting at here is like it removes the prop drilling, but doesn't completely remove the structural thing. At some point, like you could just make context for little clusters of like 3 or 4 components, but at other points you're just like, look, this is a small tight area and it grows over time. Maybe it was one component, right? Like sorry, where I want to get back to my example here. The truth is, you probably, when this was all the same page, you probably did this. Not even derived, used. What I'm trying to get at here is, if I made this example in Solid 2.0 and I wanted to use the name here, me simply doing something like upper name or whatever, upper name equals create memo. First of all, there's no await here. If I just go user dot name to uppercase, not blocking. This is not blocking. It's blocking where upper name gets used somewhere else down in the DOM. It's literally by design optimal. This is why I was trying to show in this thing. See the difference here? 1 and 2 happen here. Solid 2 and 3 happen here. Right? And by almost enforcing it this way, where there is no separation, but like 1 and 2 can't go together by design. Like you want to separate 1 and 2 as far as you can in the hierarchy, but they don't go together by design. These ones give you you have the option to separate them, but that option takes work. Whereas in the colorless system, 2 and 3 are tied together by design, which means that 1 and 2 can't go together by design, which means that like essentially you go in and you do the most straightforward thing, and that is exactly the optimal solution. To me, that is DX. I know, like people like arguing the DX case, but like, I mean, would you trade that for split effects, for something like effects you wouldn't even use? Hopefully, like, yeah, waiting inside the component seems too restrictive to me. So wait, of course, the whole point of this is that components can manage their own data. More realistically, inner would be responsible for creating its own promises, but you can do it either way. We're not experiencing things. Yeah, waiting inside the component seems too restrictive to me. I just think of how people tend to model their data in one place. Well, we try to push them into some means of co-location, and it makes sense to. It isn't something I can make a hard constraint. So composition has to flow. I consider it much less constrictive since you get to choose where the waiting happens, and it's nice explicit. Yeah, but if await always means blocking, do you know what I mean? Like, in a sense, have we overloaded the term await? If we make await mean use, have we actually constricted the language, right? Like, have we actually specialized? Is actually await now a subset of what it was originally instead of a superset? Like, are we actually limiting the language in a way that gives us less capability? Because await always meant blocking in JavaScript, don't get me wrong. But in our case, awaiting, because we can wrap stuff in wrappers, awaiting doesn't mean blocking because we don't hoist it. Awaiting just means it's awaiting a promise. It doesn't mean blocking the render flow. So if we equate await with blocking the component or render flow, then we're basically actually producing something more restrictive than something that's like more expansive. The spice must flow. Yeah, don't get me wrong. There's a couple trade-offs that come with colorless async, mostly around initial load scenarios, which we've talked about before. But generally, and actually, it mostly comes out with interaction from outside the system. That's a better way of putting it, because I mean, we've actually talked about it today. There's this physics that the trade-offs are where we started the stream from. This physics. But the thing is, these trade-offs should exist anyway. Do you know what I mean? Like, aspects of it. The more concrete trade-offs is like, if it's colorless, you might not see it. So like creating the affordances might not be as obvious, which is something that like have to get in the pattern of. But the funny thing is, when you're building UIs, you're already creating affordances. That's literally what your job is, right? You're like, someone's gonna be like, oh, I need a loading state here. This emerges from design rather than needing to emerge from technical programming constraints. As I said, I have a very different view of what DX is from perhaps, because it's not about like how easy it is to type or like how many less characters you typed. It's about aligning correctness, or like not even correctness, even optimal model with what you write. I want, when you write some code, I want it to be the most performant code. I don't want that to be a question. I don't want it to be like, oh, well, you can do this optimally by doing this. No, it's like literally the only way you can write it is the best way to write it. Like, that's developer experience to me. If it meant even typing twice as many characters, that is still developer experience. I mean, okay. Technically speaking, it's not in my graph. You can always box value this, where you could pass the promise around. It's not easy because we absorb promises naturally here. This is one of the debates I had when I was working on Solid 2.0. The fact that create memo can just absorb it was like a debate, because when it was create async, it was easier to do it the other way, because like it is possible to pull the fetch out or like store it in a memo, kind of like do this, like what Svelte is doing here. And then only like absorb it in the create async lower down, but it's not even absorbing it. It felt really pointless, because the switch from memo of promise to create async of value had no meaning in Solid, because it did not represent actual consumption, and it didn't, or the read. So it's like, we just like two-step creation for no particular reason. Of course, as I said, the promises can come from outside the system, and you can absorb them into memos in multiple locations or whatever. Like creation doesn't have to happen inside the memo per se, but the benefit of it happening in this kind of directed flow is like, this is why I like modeling async as state graph, because there's a tie between this and from props user ID. It goes all the way through the async. It's why React has changed their model for async, and why everyone's kind of flip, like, don't use effect to fetch, because that breaks the chain. So technically, yes, if you want to do extra stuff for no reason, yes. I don't know if I made this clear enough, but like the difference between 1 and 2 and 3 separate versus 1 and 2 and 1 and then 2 and 3 separate. But it has profound impact when your temptation is to actually always write it this way anyways. Even in those co-located cases, sure, it won't make as big of an impact. You can be like, this is not that big of a deal. Like, let's be fair. You're blocking effects here. So technically speaking, you don't necessarily have to block propagation through graph. What's really cool with Solid's approach was that, I think I've shown this demo, the Stack Blitz demo, several times now, but let's pull it up here again. The nested component example, right? Nested fetching example. And Rich remade this with Svelte to actually prove the point here. Naturally, when Svelte first 5 came out, they couldn't do this easily, because they had to like decouple a couple things. because of the way they did it, but like this was just automatic install. The idea is each component, like A renders B, B renders C, and each one fetches its own thing in 3 seconds. So in theory, if this was the consumption point, like if this was the await in these examples, like if we were blocking here, then this whole thing would take 9 seconds to load, not 1, 2, 3, right? So like the whole thing's under a single loading boundary. So like it doesn't matter. We don't have the ripple down effect. And because they're fetch and parallel, it doesn't really matter. It's loading it's coming in as slow as the slowest one in this case in terms of the boundary. But my point is that like this is just a natural outflowing of the thing. It doesn't require any special compiler consideration, any kind of thing. It's literally just how the system works because this isn't the consumption point. The consumption point is inside here. So we can render B without being blocked by A. And I said there are other ways around solving this problem because the whole detection consumption only really matters probably on boundary locations. But it does make, as I've shown in previous demos, boundaries really, really permissive. We can just move them around or whatever because like this aspect is you don't have to worry about where consumption happens. You don't need to inject those uses. It's just a result of the system. So making a point, you should assume everything can be async and add additional loaders around everything. See, and the thing is, this is the result of why people are skeptical about the DX on this, right? Because they're like, oh, well, now I have, everything. The thing is, you get this naturally falls out of responsibility. Would your component give affordances to show async? If it does, like if you make a button and it should have a spinner as part of its design, then you're responsible for showing those affordances. You would have been doing that anyways. If it doesn't, then that's not on you. Yeah. More like try the app loader. Necessary. Yeah, component library. If I go look at Cobalt or look at one of these component libraries, like pull it up, are they providing loading affordances in their components? If they are, then this affects them. If they're not, then this doesn't affect them. Someone else should be blocking that. Like if it stops being it's not about handling async, it's about UI affordances. Think about it. If something's loading, you can't click on it. It's not necessarily the responsibility of the button in that case. It's the responsibility of whoever is loading the data, or like in terms of like grouping this. The thing is, once you get past that initial state, everything flows naturally anyways. That's not really a problem. As long as you don't do stuff, like read after writes in your events, like that kind of stuff. Like as long as you structure stuff that follows the rules that we've been putting into the warnings, then you're fine. I think people worry about this way too much because they want to poke a hole in it. Because you're right, if you try, you can find examples that can poke a hole, definitely. But the real question is, you shouldn't be responsible for anything more than you already were responsible for. How do I know that component supports async in such a way with color? Okay. You never used color in Solid 1.0. You never used color anyways. Did you guys did your components accept promises in Solid 1.0? I'm assuming they didn't. Like, I'm thinking that they might have done something like if this isn't provided, like if I don't have a value here, show a fallback. And you would still do that. You're like, if I don't have a value here, show a fallback. But you weren't passing promises around before, so why would that change now? Like, I think it, I don't think the math has really changed here. I realize this is the thing where everyone gets like really hung up on this because they're like, oh, if anything could be async, then it could be async. Then how do you do it? Now, there are places where async reads could break, like top level of a component. Then I mean, like it becomes kind of awkward because then you're re-rendering the component. There's no thing. But as I said, if you follow some specific rules in terms of how to guard reads, the same as our, like as I said, now we're a little bit stricter on reads and warnings. The rest of the system just falls out of it. Well, I mean, people, because it suggests that it can take an async value. I'm kind of arguing that I'm kind of arguing that it doesn't, it doesn't matter. Yeah, solid was always this way. Yeah. Yeah. So like, I mean, don't get me wrong. This might be like famous last words kind of thing, and there's going to be like big pie in the face moment. But my suspicion is those pie in the face moments are going to be people trying to break the system rather than trying to actually um, follow the patterns. And I think that the challenge here is that there are some pattern differences. So like, you do have to be a little stricter. And I'm hoping that the warnings and the setup around the errors can make that happen. Yeah, value or null. Yes. The one gap, and this is it. On the initial loading, if you read a value in an event that is not used anywhere in the DOM, it is possible that an async error can be thrown. So because if it's read in the DOM, it'll be caught by loading boundary. So if it's above a loading boundary or like not read in the DOM, there is a small window at the beginning of on the very first initial load of the page that you could read something that throws. And in the past that would be null, but since we were not allowing nullable values, that will throw. This is basically the only gap in here. And the reason this gap is concerning is because it's not, you have to hit it to hit it. Like you might not realize it until, in theory, someone went to production and they clicked the thing really fast during the initial page load before the rest of the content loaded in. Afterwards, anything about will be caught likely in a transition, but there is this window, this window on initial load where it is possible if something isn't used. To be fair, if you weren't null checking the value in your event already, you would have this exact same problem, right? If it was user and you didn't check if that user was null, you would have, can't access name of undefined. So in a sense, we can't guard you from that. How would you have solved that in the null case? You would have null checked, which null checking everywhere is also not great. It's one of the stinks of representing async as being nullable. This is something that I talk about a bit in the article. The better fix you would have done is disabled the button if the value wasn't present. Note the funny thing about disabling the button is it puts an attribute on a DOM element, which puts it in the DOM, which means it gets captured by the loading boundary. Have you thought about making all signals within the scope ownership of the component be registered with the loading boundary? You're blocking again. That's the svelte problem, right? Or it's the dependency extraction problem. How am I supposed to look at the event handler? What if that event handler gets passed in from a parent? Yes. Yes, it's staleable in flight. Yeah. Which is actually consistent. They interact with what they're seeing. Yeah, sure. We can create an explicit depths API for callbacks if you really wanted to. I don't think that's really foolproof though, because I think where it gets really more interesting for a component author is that the parent not only renders you and might be passing you async data, they're also the one providing the like on-click callback. So you and your local scope can't even see it. So that doesn't solve the problem. This doesn't really solve the problem. They at the parent scope could make that call, but if they at the parent scope are making that call, then they could also, pass a disabled to your button because you expose a ready not ready condition. Your button has a disabled prop. Like if you weren't handling the affordance anyways, you probably, if you were handling it, you probably exposed a way of triggering it. And if you weren't handling it, they're responsible. Like nothing has changed here. TypeScript made null checking common, and it's also null checking is one of the most painful thing to do with signals too, right? Like because the function calls are idempotent, so like it's kind of awkward because every time you call it, you're like, this is definitely a value, and then the next you call it, like it's like I don't know that. And it's like, no, we know it's a value. I think if you click anywhere in the page before it's loaded, you deserve the error. I mean, a little. I think if you build well-designed APIs, this stuff will flow out of the language of like the affordances you built into your AI UIs. I understand how this stuff can be missed, but we're talking about like the edge of the corner of the corner of the corner, and mechanically speaking, this enforces that you do the right thing. I'm hoping this makes sense or sells. I get the pushback a bit, but like, I really think we're onto something here. Like, this is I don't know. This is really powerful stuff. We've kind of taken these physics, these rules that are true, and reimagined them through a kind of place where like we've actually pushed a lot of the harsh realities to places where you would expect to deal with them already anyways. And what we've done is kept your graph, kept your experience the way you would hopefully expect to see it. It's why I still love this, not this one, sorry. Why I still love this optimistic data example, because the difference between the synchronous app here, where you just show your to-dos, do all the stuff. There's no promises in here. I can't even see any async in here. I just wrote a to-do app that works. And I've managed to put all the actions, all the optimistic updates, all the I thought I fixed this type issue. Is this an old? Yeah, it's probably an older version. Doesn't matter. Um, we pushed all that into the data layer, essentially, right? That's an option. We don't have to push it all in there. We can break it up, modularize it how we need. But the key part is that the act of building the UI, of describing what you want on the screen, for me that's always been, the maybe it's because I have a hard time with like CSS or whatever. Like this is the part that I've always wanted to be able to model easier. You know, I mean, the data modeling is straightforward too. It's very powerful here. But what I'm getting at is we've kind of isolated the async from the UI design. Like if you need an affordance, you're not asking about async. You're not like, oh, what's the timing of this? You're not going, oh, am I like, is there this race condition? Do I care when I set loading and don't set loading? Do I need to cancel it with an abort signal? That is not what you're doing. What you're doing is you're like, okay, well, this is basically the same app as I had before, but now I need to consider if something is pending, then I should show it like this. If there's an error, maybe I should give a retry button. Okay, or if it's pending, maybe I should show this. Okay. Okay, cool. Like we kind of isolated time from the equation. We haven't isolated the need for establishing affordances for when things are available or not available. We've actually strengthened that. We've given it like you ways to query, like, is it pending, is it not? We've given you ways to look at time as flattened onto your UI plane, so to speak. We've kind of collapsed that dimension in a queryable way. But there's nothing here is like I'm worrying about race conditions. It's literally like, just I have some data, it's either errored or in flight or like pending or whatever, and just show the thing that I want to show. Everything else takes care of itself. Dude, you're on something. In the future, we're gonna wonder how we ever lived without this. Yeah, we'll see. Maybe this is too late. Maybe AI will just do everything, and no one will even care about this kind of stuff. Okay, well, there's a couple mechanical things. I spent longer on this than I expected to, but there was a couple more mechanical things that I actually want to show, but we're actually already at like 5 hours, which is kind of unfortunate. Because I actually wanted to. I mean, I don't have much this week in JavaScript, to be fair. I don't care about Vercel versus Cloudflare. Honestly, most developer news just doesn't interest me even remotely these days. No one's talking about actual stuff and approaches to building things. They're all just saying like AI, blah 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 blah. You stole this from me, blah blah blah. Like really, just like drama. I can't hear. No, what I want to talk about a bit here is I want to pull up the repo, and I want to show an example here because I think it'll help. Not it's fine, solid.js. Because I want to get into some more mechanics here, and I think it'll be interesting to do so. These should be fixed now, but I've showed this on stream. But I think this example that was made by Mizulu is actually really relevant. It's called the double. So like a lot of these were bugs that I fixed, but there is one of the ones that was actually not a bug, and I was like, this is not obvious, and we should talk about it. Is it this one? Oh yeah, beautiful. All right, let's dig into this one for a second. Or it's broken. Lovely. Okay, that's fine. I can demo this in a different place. Yeah, let's demo this in a different place. What's the best way to demo this? Yeah, okay. Okay, let me take my multiply divide example because I want I think this is really important to understand about the model, and I want to let's use my divide example. Yeah, let's do this. Okay, I think some people have seen this before. You click, you go, and you can click it multiple times. It only settles once. These are all separate async reads, but they all get entangled, and you get the smooth thing. And the key for why this example is so cool is I literally started an example with no promise here, and it just is a bunch of memos, and then I just decided to make it async, and I essentially I don't have to worry about null checks. Like A is actually an accessor number, so on. N is always going to be held where I want it to in the past, arguably. Here, I'm actually purposely tearing, so like 12 gets ahead of 12 because I use latest N. But let's do this. Let's remove the latest for a second, and I want to show you all something. See, if I do that, it's not going to move, and this is the default behavior. It'll stay on the number until it's consistent. Now, what Mizulu did in their example was they moved the button outside of the loading boundary. And I think this is important to understand because so far this is the same, and I click it like 10 times. But one thing that I'm doing here, if you've noticed, is I'm actually passing a setter function. So I'm incrementing it by n+1, which means it's actually getting the latest value. Incidentally, that's just how we work. If I changed n to actually read things, so it reads the stale value, right? So it actually does a reactive read. It's not like applying a callback function on its previous value. You'll see if I click it multiple times, it can only go once. So I click it 3 times, but it only goes up once. This makes sense because it sees the same stale value and it can only go once. So if it's on 2, it's only going to see 3, and then it tries to click it again, it's going to see 3, it's going to see 3. This makes sense, right? If this was latest n, then it would be the same as the callback form. But essentially, now if I make this timeout longer, let's say like not random, if I actually make it actual 500 milliseconds for each one, let's make it even longer. Make it 1,000. 1 second. You see, as I'm clicking here, it stays on 2, even though I click it like a bunch of times, right? But and this should make sense to people, right? Okay. We're loading, and then we show all the state consistently. Like obviously, it's a nice affordance to get latest, but the interesting question is, what do you think happens if I click the button while the page is loading? Like a bunch of times. Does anyone want to guess what happens in this example? Should it behave any differently? So here we know But my question is, while it's loading right now and I click it a bunch of times, what do you think is going to happen? Chat, I am going to wait for you guys to respond because I don't want to ruin it. Okay, Robbie says it'll go up faster. Why will it go up faster, Robbie? It will go up, and I know. Yeah. So is it the people who know the answer are the only ones responding? That's fair enough. It's not about replaying events. The page is this is client side hydrated or whatever. Everything will crash. No. Are you guys ready for me to do it? I'll give you a moment longer to guess if you want, but let's do it. All right. Last chance. All right, I'll do it now. It went up to 11. In fact, as I kept on clicking here, I could actually hold off the loading going away. Got to 30. Why is it like this? It updates right away. It doesn't hold. See here, we're holding, and then it updates. Isn't that weird? There's actually a really good explanation for this, but because AI saves consistent. Yeah, there's nothing to contradict it. The backend will handle it. No, it's because it. So secret little goblins counts the number of clicks during hydration. No, this isn't hydration. This is completely client side. The app is fully hydrated by the time, like like there's no hydration. The reason that this happens is because there's nothing to contradict it. We only need to hold the count because there's something to contradict it, because we need to be able to show that 10 divided by 2 equals 5. N itself is not async. It gets held up because you can't update the number while showing A, otherwise you'll get tearing. But when it's loading, like, there's nothing to tear, essentially. So it can just process it immediately, right? There's no dot on this either when I'm clicking on it. It's not pending while I'm clicking on it. Now it's pending, but there's no pending while I'm clicking on it right now. And it defers loading because it does load it a number of times. It cancels the previous ones. We have built-in promise cancellation, essentially. But that's basically the gist of it. Now, obviously, it's weird that I click this 5 times and it only goes up once. And here I click it like 10 times and it goes up faster. So arguably the behavior you want isn't n plus 1. It's latest n, or, simply this. As soon as I change it back to this, then you get the 5 right away. And when I click here, you get the 6 right away. Like, so now it's consistent. And when I click it a bunch of times, I still get the number of clicks aren't lost. And if I go back to this being latest n, so you want to show the updates right away, there's no inconsistency between this and this, because that's the affordance you want to do. That feels much smoother, obviously. But I did actually have to make some considerations here, right? Because the default, but like what I'm getting at is I made this decision based on like a local decision. I decided that my affordance is like, I could, with the button increasing faster, I could choose not to show the is pending. Like my affordance could be just the fact that this updates. That could be my decision. But what I'm getting at here is that like it is important to understand that loading boundary is a boundary that guards. If the async read from ABC here doesn't escape the loading boundary on initial load, which means that n is not pending, or like n can update right away. Yeah, this makes sense from a system where it's verging on being counterintuitive. Yeah, and to be fair, this is how React works too. I think that's probably how Svelte works too, I imagine too. I'm not sure. Yeah, I imagine. I mean, I've already been doing demos that were closer, like the to do MVC type stuff where you're managing a list. This demo is not going to. I don't think real world case is going to actually help explain this demo anymore. This like this is another one of those ones where what are you doing jamming the button while the page is loading? You know what I mean? I this is the this is the funniest. I have to test and make small examples to show edge cases, because in the real world you just don't tend to hit, like you will like on occasion hit these edge cases, which is why we have to account for them. But like we're not setting ourselves up to try and hit the edge cases. You know what I mean? I have to account for them so that like when your app scales and when you get to a point where you hit these things that they're handled properly. And this is why I'm very thankful to the beta testers, because the type of people who hang around the solid Discord are exactly the type of people who want to break everything and poke holes in everything. They want to create crazy demos so that really show off like the capabilities, and they also want to show their cleverness. So like I get great examples of people trying to break stuff. So yeah, I mean, what's a real example? I just said something like to do MVC with affordances is very similar to like a Trello board conceptually, which could be a real use case. A lot of times, the funny thing is these little cases that we're focusing so hard on in making these demos are like so on the edge of the thing. The real win is just being able to write the code like normal and not have to worry about these edge cases. Like let me see. Give me a second here. I'm gonna open Discord in my other window for a second and see if I can pull out some examples that the community have been making using Solid 2.0. I think Gabriel's still here. I think we just sure saying everything stays the same is mind blowing. Yeah, the two MVC examples are really great. What I wanted to actually grab was that Gabrielle had an example that was like a chat app that was built on this, and I think it's in a working state. I need to see if I can find it. Is it the Sync Engine chat? Yeah, let me see. Yeah, you guys can see it. Yeah, sorry. It's all good. Hopefully this demo is working. I might have grabbed a bugged version of it. I love this example. What was this example? Format temporal zone. So what are we doing here? Chat app, create projection, which is an async iterator, querying messages. Push store, create optimistic store. I don't have enough context probably to to look at the implementation completely in here. Chat pane, what's in here? Badge, scroll behavior, message list, message bubble. I just love that. Like most of these look like they're just dumb UI components. Do you know what I mean? Like they're just doing stuff like synchronous, nothing too fancy. Props children. There's a wrapper. Yeah, okay. So almost all the logic, this is some special scroll behavior. Almost all the special logic here is a for loop, which is keyed false. So it's by index. I wonder if repeat would be good there. It doesn't really matter. This might not even be the latest version. All the logic is basically the chat app component, right? So it's basically we create a projection, which is an async iterator, and then it just gets the messages and yields off. And then the optimistic store mechanism messages. See how does that, where are we setting our optimistic messages? We have an action that sends the messages, sets them optimistically, pushes them on an array, and then it waits on the API to send the messages, and then it looks for the message ID. Yeah, I get it. So basically when it gets an ACK from the server, like it gets the message back, it knows that it's done its action. I hear that some things like Convex automatically like hold your request till they know you've received it on the client, but this is cool. So this is basically a fully streaming chat example that's just using async iterator protocol. Like it's fun. Like there's no imports here, right? Like this is literally like just built purely using our primitives to basically have two chat apps. They work both ways. So I go hello, yeah, and they what's up? Yeah, I mean, I did a bunch of fixes since the last time, so now we can actually have the streaming async iterators work, and they have multiple modes, which is really cool. For hydration, you can either choose to do the default where it just streams from the server all the way through the hydration, or you can do hybrid where it streams the first promise from the server and then picks it up from the client. I mean, I actually got a demo I could probably show off here to that effect. Why is this still here? The weird part is, did I close one of my windows? I feel like I accidentally closed. Like where did, yeah. Oh, it's because it's full screen. Haha, it's fine. Um, uh, I'll just copy paste this into chat in case people want to check it out. I don't know how presentable it is. I know we've been working in bug fixing throughout this whole demo, so but what I wanted to actually look at was uh, quickly look at a couple of like silly little demos, incremental SSR incremental iterators. I made this example on stream last time and it didn't work. Remember? Um, where it pushes into a list. And this is actually kind of a cool API just on the side, because what I did was the projection is a stream, right? That pushes values on. So it's actually incrementally. It's not sending the whole list over the wire each time. It's literally just adding an item to the end from the server once a second. And then the client just appends the item on the end. So we're not actually sending the full list. We're actually doing incremental pushes from the server during initial SSR. There's no additional requests or anything. And what I did to actually prove this fact is I put is server. See, Stacklets has this funny, it's not, I guess not funny, but Stacklets will show you server and client console logs in the console. That's how they forward them through. So I actually had to like prove that C chunk true. It's actually running on the server, these chunks coming in. And what we're actually doing, if I look at the, maybe I can put this in a different tab. Sometimes I have problems with Stacklets from a security standpoint. Oh, it looks like my computer is low on battery, even though it's charging. It's charging slowly. Cursor is killing it. Okay, let's kill Cursor for a second. Sorry, maybe that'll help it recover. I was trying to build a signals library from scratch using Solid's tests. I wanted to actually see if I could do the vnext thing against myself. We can worry about that on a different stream. So, hopefully our computer could start charging. I'm only at 7% left, so that's kind of bad. Let's quit. Why is Chrome being weird? Oh, there it is. Okay. Okay. So it's still telling me that Cursor is using a lot of it. I think Cursor's done now. Is it still sitting there in the background? Okay. Anyways, let's bring this back because, okay. So, but one thing that we can do that's kind of cool here is instead of doing this, we can change the SSR source to be client. Let's hope this works in this version. But if I change it to be client, now same demo, and what you're going to see is false. Now it's the client side making the connection. There is one difference though. There's no loading boundary because it never suspended. It literally just picked it up on the client and made the request on the client. So, I mean, this is good for like tapping into async local storage or sort of like async storage, like local storage type stuff, but it's probably not like typical for this use case. But the real fun one is hybrid, because with hybrid, if this works, is it should be true for the first one and then it should be false. Okay, and I have a hydration error in this example. Hopefully I have to fix that now, but see how it said true and then false? And then picks up the stream. So it actually serializes the first value from the server and then continues the subscription from the client. And this is all just a matter of choosing what your source is for your data fetching. And make font bigger. The font's actually already kind of blown up. What are we at here? 125%. Usually I have a hard time reading my screen if I get any bigger than this because the code doesn't fit. Anyway, just kind of showing some of the stuff that we've been doing with the async boundary stuff. Okay, so there is... How is it skipping? That was a fun part because you have to understand it's doing incremental updates. So I actually had to eat, because if it was yielding a value, that would be easy. But if you look at it, it's not actually yielding a value, it's actually mutating it. So I actually have to eat the proxy has to actually eat the updates on the first iteration. So it takes the server serialized state and then replays the first one. But then like basically when you push or do any mutation, it just basically eats it. It gives you an object that is mutable and you can read and is self-referencing and all that kind of stuff, but it doesn't actually apply it to the underlying draft. It doesn't. I mean, there's not much you can do with the async iterators. There's not much in their protocol. You're going to error out and you're going to get an error boundary. You're going to do what you need to do. Yes, we can't skip it. Yeah. So technically, yeah. So if there's a log next to push, you'd still see the first value repeat. Yes, exactly. Yeah, we can't stop the first thing from happening. But this was a good example because it was a push. If it was a yield, this would be really easy, right? You just skip the results. But because it's mutable, yes, it does run on the client. But it's kind of like the way create async runs on the client. Or not create async, but like for promises, we also run on the client and we kind of like dummy out the promise so that we don't refetch because we have to collect the dependencies. So it's a similar trick basically that during hydration, we sort of we have to run the code, but then we kind of patch it so it doesn't do the thing we don't want it to do. In the case of async iterators, I can't promise that it's not going to run the promise like normal data fetching, but I think, but generally that's the kind of tact I've taken here. That's so funny. It's still showing cursor using significant energy, even though the cursor is not open. Anyway, that's fine. Okay, what I wanted to talk about next related to this stuff. Yeah, so I think the main one there is kind of what I was showing before, which was like this idea that if you have a graph, right, and you have let's make the screen write something on it. So here's your like signal, right? And then let's make this red. And then we have something like async derived from it. How does this show this? Yeah. White. And then let's put blue, which will be our effect. Like if you have this kind of chain, where the loading boundary happens, I'm trying to think of the best way to show this, but essentially we don't let me stop. Delete. We don't consider things having. I'm gonna draw something up here or use a word. I'm gonna write transition, okay? And transition is gonna be brown, I guess. It's gonna be like do you have any more shapes of a diamond? Yeah, I don't know if bring to front. I don't know if my diagrams here are going to be very useful here, but conceptually, the way this flows down is when we hit our async update or async signal, at that point, until we hit something async, no transition exists. We just kind of collect the nodes in a global queue. And then when we hit something async, we go, okay, create a transition. Dot 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 this. Let's make this a little bit get you. We like create a transition, but the transition doesn't do anything concrete. And then when we finally hit our render effect and it holds, at that point, it starts bubbling up its owner graph. So this is a dependency graph here, okay? So dependency graph is white, let's say. Then it looks up a different graph. It looks up its owner. So let's go here. Let's use blue. So it looks up for its owner. And in our case here, like these might be the same owner, they might be a different owner. We're gonna make this transparent. These can be where these owners don't matter, but it walks up its ownership graph and it goes, hey, I'm async. And if nothing gets in its way, it'll get to the transition and the transition will go like, okay, what, like, why did you error? You errored because of async. We actually communicate the node along here. So then this async node becomes registered with the transition and we know how to wait for it. However, if on the way up, it hits a wall, and by wall I mean like loading boundary, that communication never gets up here, and this loading boundary goes, ha 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 ha, I will hold on to this async. Yeah, so let's get loading, you be there. Yeah, sorry. The green arrow is gonna be, so this then goes to here. Indirect, yeah, my arrow drawing is terrible. Because like essentially if it hits the wall here, instead this goes to here and it never makes it to here. And that's like mechanically the core of the transition mechanism. And the key part is loading only happens initially, generally. I actually added a new prop that if you want to trigger loading to start again from above, you can. The biggest problem with suspense is if you have some random async down below, it'll just keep on unmounting on you. But one thing that occurred to me is that sometimes you actually might want to isolate the change. Yeah, that's actually what I wanted to do. Do we have the divide example anymore? I think I undid all the changes in it. Let me go back to it. Yeah, so let's undo all the changes in here. Whatever. Save. Let's go back. In the divide example we were doing earlier, where we were you know, locking it up. So let me see if I can do this. And now it should lock up. Yeah, this older demo doesn't have HMR. And then, oh, but then I'd have to update it to the latest solid, wouldn't I? This is like experimental 16. Let's fork it. Just yeah, let's fork. And then let's move to beta 4. Beta 4. Beta 4. Beta 4. It's funny because now that I have Beat plugin, this one seems like a little bit outdated. But okay, let's go here. Let's make this N. Okay, good. If we wanted to, we could say on N. And no, I hadn't tried this yet, so I was hopeful that this would do what I wanted, but maybe Maybe this is not working yet. Okay, lovely. Not working yet. Okay, that's fine. The idea is that if you said on n, it means that whenever n changes, we reset the loading boundary so it can go loading again. What's cool about this is you can control it from above, so you can make the decision, like let's say you want to kind of key it by page or something, and that way you can isolate these changes that happen above and not wait on the stuff below, so you can keep the stuff faster that way. But the key is the important part would be that random async happening below, unless it was triggered by this change of n, wouldn't cause the loading to reset. Basically, other async, it doesn't matter. This is you controlling it from above. Of course, demo's not working, but what else is new? I'll look into that. But yeah. I'm guessing a lot of the changes to signals must make them very open to sync engine integration. Yes, yes. Like I saw sync engines and I'm like, this is fine grained over the network. Solid is fine grained on the thing. This is the perfect pairing. If you care about sync engines, you should be using Solid, like no doubt. So I wanted to. A lot of this thinking is to make that seamless, essentially. Errors in green. Yeah, I don't know. Whatever. It's fine. I need to work on my way of explaining the model better, but essentially boundaries have the ability to stand in between. Transitions are global, boundaries can stand in the way. Boundaries are resettable, but generally they only run once unless as the default behavior, which is where you kind of want to be. Because you don't want things jumping out on you out of nowhere. And optimistic updates are just another layer on top of the transition. But I don't think I'll get into a good graph of drawing them today. I thought maybe I would like explain how optimistic lanes layer on. But if I can't visually show this properly, I'm pretty hopeless to visually show that. Let's move on. Okay. I think it's just time to wrap up with a little bit of this week in JavaScript. Chat's getting quiet. I can tell it's the end of the day for all you all. Give me a second as I split modes. All right. I have so much open stuff right here right now. Just closing all the crap. All the crap. All right, so what do we got? I'm actually like seeing if I actually have anything. I feel like I literally released the article and okay, yeah. Is that? And sorry, 2 seconds, chat. I'm just getting everything opened up. Okay. All right, cool. Let's go back to here. Let's go back to here. Beautiful. And then let's go back to here. Yeah, okay. Yeah, I don't have much this week, but that's good. All right. Let's share my screen now. Talk about this week in JavaScript, which honestly isn't going to be that this week in JavaScript oriented, I don't think. In general, because I mean, I highlighted that story with multi, but I don't even know if I want to talk about it that much. Okay, so Yeah, I'm gonna start with solid stuff. It's easier. Saw this, thought it was really cool. People always ask about solid on native. The native script guys are very on the, like they're very quick to kind of jump on these things and make sure that they happen. Uh, Tan-stack router solid with Vite, which is a very cool story for us, obviously, because Tan-stack router is very cool given its TypeScript routing. And here you go. This probably could be a really awesome way to develop on mobile using solid. Then there's my HackMD. What's this one here? Managed to get Vike, SolidJS, and Spacetime DB working. The instant sync is so fun. Feels like Convex. Yeah, I like Convex a lot. I saw their sorry, this doesn't go here. I saw a demo of it ages ago, and I've always been really impressed with it. It's the challenge has been people like as much as like companies have a certain reality they have to deal with. I think Jamie actually had a tweet that I saw. Yeah, because it's a pity the comics entertainers still focus on React, blah blah blah. My favorite is Solid. I'd argue it's better designed engineer than anything I've seen, but alas, responsibility to focus on support our customers use. I'd love to be able to invest more attention in other cool frameworks like Vue, Salt, or Solid. So, yeah, big fan of Convex, big fan of Jamie. I would love to see better solid integration, but we got to prioritize. I think with 2.0 coming out and the push there, this thing will naturally kind of come out of it. But big shout out to Jamie and Convex just as an aside. Sorry, I know that had nothing to do with anything. I just what was I looking at? Yeah. The key point is you saw in the chat app, we're getting to a point where build your own sync engine might be a thing. And it could even start from like not even a sync engine. The kind of optimistic UI that we're building in Solid, irregardless of the transport layer, essentially, doesn't literally matter how the data gets thing, can give the sync engine feel without even having a sync engine. So like, yeah, I mean, we're definitely on our way there. Yeah, okay. So that's it other than that other story. Let me go here. What do we got? Yeah. Yeah, a lot of part of advocating for Solid is having to defend React first. A lot of the loudest anti-React takes fixate on ergonomics or vibes, not the actual architectural issues. You can't explain Solid's advantages until you clear that fog. This was a precursor to this article. I knew I was writing this article when I wrote that tweet. I was just like, it became really obvious to me. I was like, I'm gonna have to write a post where I basically point out why React was right and defend it. At the same time, show where the shortcomings still are, but be very clear that the things that people like to blame React for aren't the right things. It's tiring after a while when people are arguing over stuff like syntax or like how many characters you have to type or whatever. It's just like there was an interesting actually I saw it on Reddit where someone showed that like the least tokens used framework was Marco, and then like Svelte was like third, and then I looked at the list for a second. I was like, this is like syntax compactness. It's not actually probably saying how easy it is or hard it is to actually create the examples. It looks like someone just took like component party JS or whatever, where you have all the examples and they just counted the number of characters of it. It doesn't actually suggest if AI has a harder time or it requires more thinking or whatever. It's basically like which framework has the least syntax. And as everyone knows, Marco is the most compact JS framework, right? You type the least in that one compared to any other framework, even Svelte. So like, of course it won. So, yeah, it's interesting. We don't know what metrics really hold up, but I definitely feel like we don't have the right measurements yet. Let's talk about my actual AI article, the one that was actually written by AI, for a moment here, because I don't think I've talked about it too much. It was after my last stream. I basically asked AI why Solid was a good choice. For all those guys earlier who were like, "Oh, what about Remix 3?" This is my response to you. I guess I could have brought this up earlier, but this is what AI told me. You guys can decide if it's relevant or not, but software is entering a new epoch. The era of writing code is giving way to the era of systematic orchestration. As AI agents pour unbounded amounts of imperative logic into our repositories, the limiting factor is no longer human output, it is complexity absorption. In a world where machines can generate infinite working code, the frameworks you choose become only your defense against temporal drift, race conditions, and slow gravitational pull towards technological entropic collapse. The question is no longer how do we write code, it's how do we ensure that code, human or AI, remains correct over time. Solid 2 answers this question with a single principle. Determinism must be structural, not stylistic. I mean, it's a good summary of what I was covering on the stream in terms of the shape of the APIs. The ending of the loading Boolean error. This is kind of like direct response to like the remix thinking. As I said, to be fair, I didn't write this. AI wrote this. This is a completely AI generated. Most frameworks still treat async as an afterthought. A promise resolves somewhere, a Boolean flips somewhere, and the UI is expected to stay in sync. This is the root cause of modern UI instability, a temporal desynchronization zone where data and interface drift apart. This model was fragile when humans wrote all the code. It is catastrophic when AI writes most of it. Solid 2 replaces its entire class of problems with a new primitive, the temporal tuple. It's a funny name. Well, all they mean is that we have like we have latest and value, or we have optimistic and value. Like we basically view all state as now and the future. They chose to call it a tuple. It's not a literal tuple. It's just the idea that you can declaratively show something. Let's see what their explanation. Every reactive value carries both the now and the future. Async is no longer a side effect; it's part of the value's identity. This eliminates the need for ad hoc loading flags, effect cleanup heuristics, and the endless patchwork of fixes that accumulate around async code. The runtime owns the timeline, so the UI cannot fall out of sync with reality. Determinism by construction. The gap between actions resolutions where bugs live. Traditional frameworks ask developers or AI agents to manually bridge that gap with effects, guards, and cleanup logic. This is not engineering, it's gambling. Solid 2 removes this gap entirely. By elevating the feature as a first-class part of the signal, the runtime constructs a timeline projection architecture. The UI becomes a pure projection of the value's temporal state, not a reaction to its events. This makes the entire categories of bugs structurally impossible. Stale closures, race conditions between overlapping requests, flickering due to mismatched loading states, UI tearing during async transitions. Where other frameworks rely on discipline, Solid relies on invariance. A runtime that can absorb AI generation code. AI does not write elegant code, it writes maximally literal code. In virtual DOM systems, this leads to over-rendering, hook chains with hidden dependencies, effects that accidentally rerun, states that drift because the framework cannot see the graph. Humans eventually lose the ability to reason about the system. Solid's fine-grained reactivity turns this dynamic on its head. Even if the code is sloppy, repetitive, or overly imperative, the runtime constraints put into transparent, observable graph. Computations become explicit, dependencies become explicit, updates become surgical. In other words, even bad code becomes predictable code. This is the only sustainable architecture for future where AI is the primary contributor. 4. Stability is strategic assets. Frameworks often chase features, abstraction, or syntactic novelties. Solid 2 takes the opposite path. It invests in permanent primitives. These primitives, signals, timeline, boundaries, those aren't our actual primitives, but good try AI. I guess boundaries are and signals are. I don't know what timelines are. I guess they're talking about like the pending stuff. Form a stable contract between your logic and screen. They are not patterns, they're not conventions, they are mathematical guarantees about how state flows through time. This stability is not conservative, it's forward-looking. As code bases grow beyond human comprehension, stability only becomes the only way to maintain velocity without collapse. Solid 2.0 is not designed to help you write code faster. It's designed to ensure the code you write or the code your agent generates remains correct by default. Yep. The future belongs to deterministic systems. The next decade of front-end architecture will not be defined by JSX versus templates or by compilers versus runtimes. It will be defined by whether the system can guarantee correctness under exponential code growth. Frameworks that rely on human discipline will fail. Frameworks that rely on runtime invariance will endure. 2.0 is the first framework built on this reality. It's not a UI library. It's a temporal contract, a guarantee that your interface will always reflect the true state of your system, no matter how much code is generated above it. I hope so. AI seems pretty positive. It tends to be. How's your overall feeling so far? I think there's a couple places where I get kind of discouraged at times where I'm just like, oh man, I can see why that wasn't intuitive. But then when I go back at it and I go, oh yeah, but it is actually the reality. My biggest concern is making sure that the education is. I actually don't. I think the API shape and stuff is generally good. Like I think in a sense it rolled out. Like as I said, it's not something invented. It kind of like was discovered. It's kind of like following the physics. So like while there's small pieces, like adding on to loading or things where we can like do these kind of like slight adaptations that can fit some patterns generally. Generally, for the most part, I think we've actually gotten to a really good place, really nice design. Like stuff seems consistent. Like over and over again, I hit like these issues and stuff, and I'm like, "Ah, that's why we have split effects. Like literally, just like I'm like, oh, this would have been a problem, except the place where it becomes awkward is like legacy APIs and stuff like actual like tracked effect. Like I had to fix a whole bunch of like do a whole bunch of special casing just so that we could keep like on mount or on settled as it's called now, or keep like effects not being split. Like stuff like that is the biggest source of my concern, because as I think it's important to like still continue to support people in certain ways, but like the things those things are doing are really terrible. And it's hard because they're like people like I want to be like this, and you're like, no, you don't. Like everything like and it's not like something like, oh, just because of this one reason. It seems like everything flows out of the system that way. You start doing more work and you're like, oh yeah, split effects saved us again. And it's almost like a hammered repetitive message as the design progresses that just supports the thing. Now obviously sometimes that's self-fulfilling because like you set the constraints in the first place, which means you come to that inevitable end. So I recognize that as a thing, but it feels incredibly consistent, and reasonable, from where I'm sitting at least. Most of the bugs there's a lot of bugs, which makes it hard to kind of see the full picture. But then some of the other stuff, behaviors are just weird behaviors, like where you know, like people are doing stuff that is unexpected and really should be forbidden. A lot like there's a lot of the bugs. I looked at them and I was like, we should just throw an error there, which is odd, but it's kind of like my picture of the behavior of the system has never been clearer. Okay, I guess that's the best way to put it. Like a lot of the ambiguities are gone. What else we got here? I recently attacked. Oh, Sublime. Okay, let's go into the bookmarks the last little bit. There's not much to say here. Theo actually covered in his video, and I thought he did a really, really good job. Because like anyone who knows Sunil knows how awesome of a guy he is. But basically, long story short, Vercel had kind of like a bash thing layer that they set up on top of their infrastructure, so that AI agents could use bash in a safe way without like getting to the underlying infrastructure. And then Cloudflare or Sunil saw it and was like, hey, this is actually really useful. We should do something similar. But obviously they don't work on Node. They work on worker D or whatever their underlying thing on their workers. So they had to, a straight point won't work. The challenge here was that just bash was, is this article still here? The gist of it is just, it's basically not stable. It's like literally experimental. Like it's not in a place where someone should like copy and fork it, so to speak. But it's obviously the need is there, and Sunil was just testing stuff, but he released it through a public Cloudflare official repo, and they basically he removed all the stuff that wasn't necessary for their environment, and because of the whole Vercel Cloudflare thing going on, the whole thing kind of got really blown up. Like, is this Cloudflare trying to steal Vercel stuff and remove the security and all this stuff? And everybody chimes in. I think Malte and Sunil talked and then everything cleared up. It's just funny, like whenever there's these dramas, things get like way blown out of perspective. You know, Sunil's like, oh, Cloudflare's mission is to fork the entire development ecosystem to destroy open source. VNext was an excuse to swindle developers into. Does anyone take this guy seriously anymore? It's fine, whatever. It's kind of like when I read Donald Trump. I just can't do it anymore. I'm sorry. Let's just continue. The gist of it is that these guys made up and it was just a misunderstanding. The thing is, it's always like the overreaction things where people end up saying the thing that they like should regret. It's usually not the original thing. It's like the way everything blows up. Like I remember when the whole remix docs scandal stuff happened with us, and like the guy from one of those like venture capitalist companies, you know, that scooped up all the open source companies, was like trying to like flag like like Matt Billman and be like, oh, you know, blah blah. And it has nothing to do with Netlify at the time or anything. So it was just like people trying to like stir up crap when they have no business to, because of like getting on the drama. It's unfortunate, this scenario, and that's all I really have to say about it. I think I'll leave on this last AI note because I think I saw this from Deb today and I thought this was funny. So this is going to be injected into every coding agent system prompt, huh? So much for AI is good at React because training data sets. I mean, ensure page listing for React code, prefer modern patterns include use effect event, start transition, and use deferred value when appropriate if used by the team. Do not add use memo, use callback by default unless already used. Follow the React compiler guidance. Sorry if I didn't like this. Obviously, they will always like being the newest of every framework, but AI still works better with React than new frameworks like Vue. React is more native to JavaScript. I don't even know if I want to read these responses. I feel like I might like just insult people that I forget it. Let me just focus on what I actually wanted to. The thing is, the AI React is still evolving, and these patterns, including the compiler, including all this stuff, means that React code is changing. To the point that I don't think this change is hard to absorb. I think AIs have no problem absorbing this sort of change. So I think just the whole I think this whole AI is good React training set data thing is complete garbage. I've been saying it for a while, and if React can absorb that, or if the AI can absorb this easily, then it can absorb Solid or something else just as easily. And people pushing this thinking are just, yeah. I mean, I don't even know what to call them. I don't. It depends on what their motivations are, right? You know, it's a spectrum between swindler and ignorant. So I think this. I think Ben Davis just did a video about this recently, talking about like Svelte and like how AI is no issue. And I've found the exact same thing with Solid. You know, like this is not the argument to make. And I love seeing it crystallize like this one. Like basically, React's introducing multiple new primitives that replace other primitives not to use, and also following different code writing standards thanks to the strictness of the React compiler. Like these are all good things to do. It just suggests that React now is not the same as React was 5 years ago, when like these models were trained, you know, generally speaking. So like there's probably more React code using these proper values than there are some other frameworks codes, but I think the numbers are a lot closer between this stuff and like say picking up Svelte or some other framework. Definitely Vue. I mean, when did Vue switch the composition API? 2020? Yeah, so that fits in. Like, you know what I mean? Like this is much rarer of a breed. So obviously if React keeps on winning, React keeps on propagating, but like at this point, it's your own self-fulfilling prophecy. Don't think it's anything else. Recently, AI wrote me a React class component. Well, there you go. Still works. Current LMs are quite good at writing code in total law of language with minimal examples. I don't think this is a real thing anymore. No, it isn't. It's funny that we have to call this out though, because I mean, there's people who think this, right? Dev actually humor him? No, good. Um, one thing is, then yeah, the one constant here is change. I don't know how often we have to like debate this with people. Every area doesn't know how to use your deferred value. I agree. Yeah, someone's from the Svelte community. No, the reality is this is just not a thing anymore. AI is generally good. All right. Yeah. I'm done too. I gotta go too. It is almost 4 o'clock. I've streamed for quite a long time. Only went a little longer because I started late, but I'm actually gonna look and see if anyone else is streaming, see if we want to raid anyone. But to be fair, except for last time where strangely Theo was started streaming right at the end of our stream. Usually there isn't much for the Friday night crew. Yeah, it's all good. You guys all have a great weekend and hope you learned something from the stream. It's gonna be a couple weeks. Oh yeah, there's one more little bit of news. Gonna be doing a Solid Start stream coming up in a couple weeks. Solid Start 2.0 is close to release. It's gonna come out before Solid 2.0, and it's gonna be update for Solid 1. Attila has like a whole thing he posted, but I probably missed. I forget if we were gonna publicly announce something. Let me see here. Actually, you know what? The discussion's public. Let me just throw this up as like one last little thing before I go. Let me throw here. Roadmap, start V2 and ecosystem. Hey folks, long time no talk. Our last announcement was done at the beginning of DaVinci work. We have successfully completed, and I'm happy to let you know that Solid Start version 2 is used in production already in real world apps like Open Code Console. Yeah, nice. As per the last announcement, our plan to maintain Start and Solid in version lockstep. It seems possible the works in Nitro V3, Solid V2, and Start V2 converging to a similar release date. We are now deciding against this plan in order to provide a better developer experience and migration plan for existing Start version 1 and V1, Solid V1 apps. Yeah, exactly. Like you could tell that we were all converging around the same time. For us, the ideal support Solid V2 would also need breaking changes in router and meta packages. However, since the team has managed to keep the DaVinci effort with minimal breaking changes, we believe it's worth the effort to create a stable release in the new architecture in order to lay down incremental migration steps toward the future Solid. Upgrading from start V1 to V2 requires a small change just to config TS config JSON, and optionally create middleware signature. Although the internals are much different and improved, there's no change impacting your server functions, actions, or component code. I recommend you to give a try and follow these migration things. Update timeline. Remaining block can start alpha, new directive plugin, built-in server-only environment variable support, beta, once these emerge, release beta 0, collect feedback, Solid recommended server runtime from Nitro to V3, planned blah, blah, blah. Release candidate, by the time we're confident enough, the API will ship 2.0 RC, effectively deprecating Start V1 and create Solid CLI will official documentation. Solid V2. As the ecosystem adapts to the new APIs and updates in Solid Router and Solid Meta, we will start working to support V2. The likely is not certain supporting Solid V2 means V3 for Start. Yeah, though likely, it probably will be V3. Start V2 will not drop support for V1. That's the idea. If there's a chance to support an incremental migration from V1 to V2 within Start V2, we'll try that. But at this point, we're not trying to make any promises. Fair enough. And I think it's good that you didn't. We are also working on developing plugin-based system ecosystem. First package, long-awaited image component. Awesome. That's all we're open to seeing, blah, 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 migration. Yeah. So gist of it, very exciting. I'm not logged in, so I can't do anything here. But Solid Start V2 is probably going to be coming out in the next month or so, I think, somewhere along that lines. We're going to talk about it. We're going to do a stream on it in 2 weeks. And then we'll see how the beta continues going. But then the support for like we still have some time on Solid 2 beta, at least a month. So we'll Solid Start support will come a little bit later after that. Essentially, it might be a quick V2 to V3, but I think it's important that we have the updated basis, and Attila as well, that for Solid Start, so people on Solid version 1 can continue to like get updates and use the latest technology where it is today, and not be stuck in like where we've been in the past with Vinci and whatnot. So it's a bit of news. I just occurred to me, I wanted to get this out early now because by the time we have the stream in a couple weeks, this stuff will be well underway. All right. Anyways. You all have a great one. All right. Oh yeah. Actually, you know what? Sure. I don't know what he's doing, but let's raid CM Griffing. Why not? It's been a while. Kind of on my channel. Griffing. I think he's working on something in Rust right now, but it's all good. Anyways, you all have a great one. Till next time. See y'all.